बस साइन इन करा, कुछ नहीं मांगा।
तो इंस्टीट्यूशन ने
तुमने चेक कर दिया था ना?
क्या
टिक कर दिया होगा।
किस पे?
Hello, everyone. Thank you so much for joining. We will just wait for a minute or two till a few other participants as well join, and then we will be starting with the workshop. I would appreciate if you all would just turn on your cameras so that we can make this workshop interactive.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning. Good morning, everyone.
Happy morning.
Happy morning.
Morning.
Good morning, everyone. So let's just start with the today's workshop introduction and everything and all the necessary information that you want to know regarding the workshop. Before that, let me just start with the recording. Okay, great. So, good morning, everyone. Welcome to Sabudh Foundation's two-day awareness workshop program for the Jan to June 2026 cohort. To begin with, today you will get a clear list of the internship, the 2 days workshop schedule, and the topics you will be covering. And the same details are also shared with you in the description of your WhatsApp group, including your session timings, topics, and the mentors who will be leading each segment. Please take a moment to refer to that for a quick clarity. And for your convenience, let me just share the screen so that you can also get to know what all the schedule is all about and who is going to teach you in the particular workshop. Just a sec. I hope my screen is visible to you all. If anyone can
Yes.
confirm. Okay, great. So for the starting of the 15 minutes, we will be kick-starting the workshop and introducing you to Sabudh internship overview and what you will be getting in these 2 days. And it will be done wholly and solely by the Sabudh team. And then at 10:15, you will be getting Python programming essentials from basics to data analytics. Please note that this is for all the internship programs, that is AIoT, it is data analytics or data science. So it will be taught to you by our mentor Ishita Das, who is a trainee data scientist. And from 11:15 to 12:15 today, you will be getting from data to decisions, that is an understanding of the machine learning in real world, which will be taught to you all by our mentor Dr. Shafila, who is the manager learning. I request those who have turned on their mics, please mute for for a while when we are providing you the information. Okay, great. Thank you. So from 12:15 to 1:15, there will be a formal introduction to linear regression and objective assumptions and all the things which is functional form, cost function, interpretation, gradient descent, and all the other stuff you can see on the screen as well. And it will be taught to you all by our mentor, Ms. Suparna Datta. She is a junior data scientist at Tatras Data. And from 1:15 to 2 p.m., we will be giving you a break, a short break, so that you can get your energy back and you can start again afresh for the next 2 sessions. So from 2 p.m. to 3 p.m., we will be going forward with the Inside the Neural Mind Introduction to Deep Learning. And it will be done by Mr. Gurjot Singh, who is a data scientist as well. And from 3 p.m. to 4 p.m., Code the Brain, hands-on deep learning implementation, which will be taught to you by Mr. Akshay Kumar, the data scientist. Now, the day one is covered. You will be now moving forward for tomorrow, that is day two. And the topics that will be majorly covered tomorrow will be LLMs and Gen AI. So here you can see it will be starting from 8:30 a.m. to 9 a.m. and it will start with the opportunities that you will be getting at Sabudh and the career pathways in AI. And it will be a 30 minutes of session which will be given by our co-founder of Sabudh Foundation, Dr. Sukhjit Singh Sehra. And afterwards, from 9 a.m. to 10 a.m., it will be the rise of LLMs. Introduction of LLMs will be given to you by our chief data scientist and co-founder of Sabudh Foundation, again, the Dr. Sarabjot Singh Anand. And from 10 a.m. to 11 p.m., 11 a.m., I'm sorry, यहाँ पे 11 a.m. होना चाहिए. So 11 a.m. It will be from text intelligence, basics of NLP for LLMs, and it will be a 1 hour of session. And Mr. Jayapata Chakraborty will be taking the session, who is a lead data scientist at Tatras Data. And afterwards, from 11 to 12, Behind the Magic, Transformers, Prompt Engineering, and LangChains, which will be given by our Associate Data Scientist of Tatras, Miss Rushil Sharma. Again, we will be having a break to help you get your energy back from 12 to 1 p.m. And then we will be starting back again at 1 p.m. And it will be agentic AI. Building autonomous goal-driven systems, which will be given to you by Mr. Partha Sarthi Mukherjee, who is a lead data scientist at the Trust Data. And then from 2 to 3 p.m., we will be having ChatGPT in action, building smart AI assistants, and it will be given by another lead data scientist at the Trust Data, which is Mr. Bhapaditya Chakraborty. After all the things have been covered and you have gotten the gist of what the workshop is all about, what the internship is all about, we will be having a general doubt session with you all, where all the important information about the internship and the next steps will be given to you by the Sabudh team. It will be from 3 p.m. to 3:30 p.m. And afterwards, we will be having wrap up and assessments. And by assessments, we mean you will have to go through EducoLab, our LMS platform. You will be giving assessments there, and every information will be given to you in the WhatsApp group. So make sure you have joined the WhatsApp group as well. And also, we will be communicating the same with you all over email as well. So don't need to worry about the other things. So we will be giving you a walkthrough of how you can access to the EducoLab. We will be sharing with you the EducoLab credentials. Some of you must have gotten it, and some of you are not. You have not received it. You will be receiving it by tomorrow, so don't need to worry about the same. And the recordings as well will be received to you. Will be shared with you over EducoLab. So just don't stress about EducoLab and everything. Just learn in these particular 2 days. Okay. So apart from that, just give me a sec. Let me just stop the sharing. Okay. So, apart from this gist, over these 2 days, our goal is to help you all to understand the structure of the internship as well, the expectations, the learning outcomes, and the support system you will be getting throughout your program. This workshop is intended to guide you smoothly into the next steps of your process. We would really appreciate, as earlier mentioned as well, that if you can just switch on your cameras to help us maintain an interactive and engaging environment, because our mentors, when they will start joining, they will love to see an engaging audience that has come and is receiving their lectures and is getting knowledge from them and also cross-questioning them. So just turn on your cameras and be interactive throughout the session and the workshop, okay? Before tomorrow's doubt clearing session, I would also request you that you go through our main website, which is sabudh.org, and there you can see the FAQs will be there at the website. If you go through these FAQs, it will help you also get the topics discussed with us during tomorrow's doubt session. So make sure you go through the FAQs as well. And also, as mentioned in the email, the tentative dates have been provided to you all for your aptitude test and interview as well. And we will be sharing the confirmed dates soon as well. Also, you will be receiving a sample aptitude test beforehand so that you can become familiar with what the pattern of the question is all about and you can prepare confidently. We look forward to have an insightful and meaningful workshop with you all. So all the best to you all. And I can see that there are some questions in the chat box. Let me just open it. Okay. Okay. Abhijit, all the information about the internship process will be shared to you tomorrow. Don't need to worry about it. First, focus on the 2 days of workshop that we have given to you so that you can get a gist of what the internship is all about. Okay, and all the information again, it will be shared with you over the official communication platform, that is your email IDs. However, if you have joined WhatsApp as well, you will get information over WhatsApp as well. So don't need to worry, you will get information 2 ways, okay? And apart from that, yes, there will be recordings of the session as well. That will be provided to you on our EducoLab platform. So EducoLab, what is EducoLab? What LMS platform is it? All the information about EducoLab we will be sharing with you tomorrow. So don't need to worry about the same. You will get a gist. Those who have received the EducoLab credentials, that is good to go. But those who have not received, don't worry. We will be sharing with you by tomorrow. Don't need to worry. Before assessment, you will be getting all the necessary stuff. Okay. Yes, Arman. Yes, Aman. This internship certificate will be a valid certificate. And apart from that, uh, every attendance criteria, everything about the certification, please don't worry. First, go through the FAQs of our website, and then tomorrow, when we will be having a doubt session, because today we will be understanding the topics which we are covering in these 2 days workshop, right? So I would request you to go through our website first, FAQs ko jaake dekho, and then we will be having this discussion tomorrow. Okay? I hope that works
Rakshita?
well with you. Yes, ma'am.
Okay. So, hi everyone. This is Dr. Shafila. I am Manager Learning at Sabudh Foundation and I am also a faculty at Sabudh Foundation. So, there are few students or few participants who have some confusion regarding this workshop and internship. So, the intention of this workshop, 2 day workshop, is to provide you the gist of the internship. Sabudh Foundation is an NGO. We don't take any fee from the student and we don't give the stipend also. We provide free internship for 6 months in 3 fields: data science, data analytics, and artificial intelligence for Internet of Things, that we call as AIoT. So, to provide you the gist of that internship, in the middle of the registration window, we are conducting this 2 day workshop. Few people are asking about the certificate. We never give certificate of these 2 day workshops. No certificate for the workshop, no attendance for the workshop. This is to give you the gist of what the field data science is, what the field data analytic is, and what is AIoT. So that some of you have already registered for the internship, some of you may be planning for the registration. So you can just have a gist, okay, so what is this field, whether I am developing interest in this field or not. So this is what we are trying to give you. Okay. So uh, again, attendance ke, if you are attending the workshop only for the attendance, then we really do not want you कि आप अपना time खराब करो. But yes, अगर आपको सीखना है, because if you see the schedule, majorly you are meeting the lead data scientist. What Rakshita meant was, Rakshita is our training program coordinator. So basically, the Tatras Sabudh is an NGO and sister company is data science company, that is Tatras Data. And Sabudh Foundation is running this program in collaboration with STPI, Software Technology Parks of India. So that is why we said, yes, this certificate is a valid certificate. You can consider this certificate as, in few of colleges, when you are pursuing with your engineering, there is a mandatory 6 months internship program. Okay, so training program. So you can consider this certificate as your industry training certificate, because everything is hands on over here in these 6 months. Okay. And Tatras Data, so if you see the schedule, most of the faculty will be from the Tatras Data. So whether it is a lead data scientist, it is a data scientist, associate data scientist, so you will be having an opportunity to meet those people, to connect with those people. ठीक है. So I hope this internship obviously आपको कुछ फायदा होगा, इसका benefit होगा. So our first speaker is here with us. So Ishita, are you there?
Yes, ma'am.
Okay, so we are starting with our first session. Over to you, Rakshita.
So let's just start with our workshop then, everyone. And the first session that you will be getting is Python Programming Essentials from Basic to Data Analysis. And it will be given to you all by our trainee data scientist, that is Miss Ishita Das. She has joined the session. And over to you, Ishita, ma'am. You may start the session.
Okay. So good morning, everyone. Am I completely audible and visible? Can anyone confirm, please? Yes.
Yes, ma'am.
Yes.
Okay.
Yeah,
So
ma'am. Good
what I
morning.
want,
Yeah, audible.
what I want from you people is to speak, unmute and speak instead of using the chat, because I'll be sharing my screen and then I won't be able to see the chat box. Okay. So let's start with the session today. Let me know if my screen is visible to you. I think it is disabled. Can you please check, Rakshita ma'am?
Sure, just give me a moment. Can you please check, ma'am, now?
Yes. Okay. So is it visible?
Yes.
Okay. So, as we all know, today we have gathered to discuss on Python programming essentials from basics to data analysis. But before we approach to this topic, I want you people to know that have you ever Googled which is the most popular language in 2025? Can I get a quick yes or no?
Yes, ma'am.
Yes. So, which is the
Yes,
most
ma'am.
popular language in 2025?
Python.
Right now it's Python.
Yes. So for who hasn't Googled it, so let's do it together and try to find out which is the most popular language. So yes, it says it is Python. Now, what makes Python so special that everybody is today's world is talking about it, discussing about it, and the user base for Python is growing day by day. Why is it so? So before we discuss about that, we will discuss a little bit about what is Python. So moving next, what is Python? So as we could see, the definition says that Python is an open source. Open.
மீட்டிங் குள்ள போன அந்த மீட்டிங் குள்ள தான் இருக்கு
I think something
Rakshita,
is
can we please mute the people? Rakshita, it's very disturbing.
okay. Let's continue. So what is Python? The definition says Python is an open source, object oriented, high level, general purpose programming language. Since the definition could sound a little bit overwhelming to you, so let's break it down. What it is trying to say. So when we say open source, what we mean is that the source code is available to us, and what we could do is you could make changes and fix bugs. So that is what we meant about the open source, means the code base is available to us. Then object oriented, what do we mean by object oriented? Means is that it is not only based on the function but on the objects, so it has definite attributes and methods. Next we have high level language. So when we talk about high level language, what we really mean is that there are two kind of language. One is low level language, one is high level language. So when we talk about low level language, those languages are the one that machine can understand. When we talk about high level language, are the ones that the machine cannot language and are mostly human friendly. So if we in further in this session, when we will discuss about the syntax and we will see the code, we will understand why it is so much like human friendly, because the syntax is easily readable and very similar to English. Okay, and it is a general purpose language. So Python can be used in many ways in various other fields, and there are so many libraries and so many frameworks, so which helps us in many ways. Okay, now moving next, what do we have is why is Python so popular? The first question that we were discussing about. Now, as I have now only said that Python has a very similar syntax related to English, which makes us, let's say somebody is learning Python for the first time, which makes it easier, very easy for them to get, well versed with the language, so that person can understand each and everything. But if we take example of some other language, let's say C++ or C, the person can take time to sink in with everything. Okay, now as we it is a very human friendly syntax. It has, I have already mentioned it, and it has an extensive standard library. So what makes Python again very different from all other programming language, it has lots of libraries. So by importing which we can perform various other functionalities in Python, for which, like, let's say other language has to, it has to be coded. So for this Python, again, when we write Python code, it may look a very short piece of code as compared to the one when we let's say when we are writing in C or C++. Okay, So it's free both for individuals and business, and it has got a huge supporting community. Now, when you say about youth supporting communities, that uh, how this is helpful. Let's say we are facing some problem and we search it down. So very often we will see that somebody already is there that has faced the same problem, and you could get to solution easily. Also, you can get in touch with a large number of people, and you could sort things out. So that is how it helps. And also, as I have already said, Python has its application in various other fields. Okay, now moving next, what is Python used for? What is Python used for? So, Python is used for data analysis, data visualization, machine learning, AI and deep learning, and software development. There are many more, but I have listed here only five. Now, as we have finished going through the PPT, let's try doing some hands-on implementation. Okay, before we move further, it's important to know that Python was created by Guido van Rossum, and it was released in the year 1991. Here are some key characteristics of Python, which are mostly common as we have discussed earlier. But let's continue with this. So what it says is that Python is a versatile language. It is capable of doing various kind of tasks. Yes, we have discussed about it as a versatile language, and it can do a lot of tasks. Okay, Python is platform independent language. Now, when we say about platform independent languages, that Python can be executed in any kind of OS. That's what makes it platform independent. Now, why it is platform independent? Because there we have PVM, that is Python Virtual Machine. As in Java, we have JVM. So what happens basically is it gets converted into an intermediate code, which is a bytecode, because of which Python is platform independent. Okay. Now, Python is popular for its readability and easy syntax. Python supports large standards library that we have already discussed. Python is an object-oriented programming language. Python has a large community that we have already discussed. Okay, now good to know. The most recent version of Python is Python 3. Okay, so let's start with the hands-on practice. The very first thing that we will be looking into is how to print a statement in Python. So when we want to print a statement in Python, what we can simply write is print. We have the first bracket or the simple brackets. Inside that, we can write it with double quotes for a statement. Let's say I have written hello world. So if we write it in this way, what it gives us is it prints hello world for us. Now, as we have number, we don't have to write it in under quotes. So we can simply write the number. Let's say I have written here print 35A. So it displays the number. Okay. Now what we have is again, like I said, we can use double quotes or single quotes as well. So when we write with single quotes, it similarly prints hello. Okay. Now coming to this, you could see this hello is written without print. And why, like, it is giving us hello without print? That should not be the case basically, but it is only supported in an interactive environment like Colab or Jupyter. In all other platform, it may not give you print like this. And also sometimes what is noticed is that, not sometimes, usually in platforms like uh, Google Colab, which I'm using, or let's say Jupyter Notebook, what happens is that, let's say we have written the entire piece of code and we are mentioning a variable name. Then it prints the variable. Let's say we are storing a certain value in the variable, so it will print that variable. Okay. Now, as we are done with the print statement, let's see how we can take input. Okay. So yes, we will discuss about the variable if you are not understanding what it is a variable. So variable, let's say num, here num is a variable, and we are taking an input with the word input, and again like print we have the simple brackets here, and here we are writing enter a number, so this will get printed. We could also write it as like input and then after that brackets, so that will not, this is getting displayed enter a number, so this will not get, printed here. Okay, so when we write this, it prints out enter a number, then we could enter a number and the number gets printed. So print now. Let's try to run this. Let's take a number, let's say 22. So you could see that it is getting printed. Now, as we were discussing about the variables, initially who may not be knowing it, they might find what she's talking about, what are variables. So when we talk about variables, we could imagine it like a box or a storage place where we can store something. Okay, so now if I have a, let's say, box or a storage location where I'm storing something, how to identify it or how to get to it after a time. Okay, so if it doesn't has a particular location, how to figure it out? So for this, we assign a name to a variable. Let's say my var or something like that. And if we all have, set sometimes username and password, that follows a particular, rules that should be maintained in order to set, let's say, password or a username. That this must be the criteria which should be followed in order to create a username or a password. Similarly, for the variables also, which we have few rules that has to be followed in order to create a variable name. Like variable name must not start with a letter or a underscore. Variable name cannot start with a number, and it can contain only alphanumeric character. Alphanumeric character, and obviously underscore, that is alphabets, numbers, and underscore. Okay, variable names are case sensitive. Let's say when we are writing age, age, all in lowercase, and a in uppercase, ge in lowercase. In that case, uh, all these are treated as a different variable name. Okay, moving next, a variable name cannot be any of the Python keywords. So what happens is that there are few reserved keywords. Let's say we will be studying about if, else, return, and all these terms you will be coming to know about. These are what? These are already reserved in Python because they are used for a specific purpose. So we cannot use them as a variable name. Okay. So what we are doing here is we are taking a variable as x, we are storing a value 5 in x, and we are taking another value y, and we are storing uh, a name there. So we are trying to print it out, so it gives us the number and the name itself. Okay. Now, coming to a very important thing, that is data type in Python. So, what is a data type? Let's go by the definition. The classification or categories of data element is known as data types. So, I give you a certain data. So, that data must be of certain type, right? So, in order to classify that data, we have data types. It represents the type of value that specifies the operation that can be carried out on a given set of data. In Python programming, everything is an object, and hence data types are actually class, and variables are instant object of these classes. Okay, let's not go by definition. It always makes us confused. Let's see what it's there. So as you could see in this picture, Python data types are divided in this way. Let's say numeric data. When you say about numeric data, we have integer, complex number, float. Uh, Integers are basically, let's say, positive, negative values, including zero. Complex number usually go with a syntax like, let's say, 1 plus 2j, which contains an imaginary number. And then we have float. What are float? Float are the numbers which has decimal in it. Okay, the decimal numbers. It could be both positive and negative again. Now, coming to dictionary, what are dictionary? Dictionaries are key value pairs. We have example. We will look into it. If you are feeling confused, do not worry about it. We will discuss. And Boolean values are basically true and false. Okay. Now coming to the another one, which is set. So when you talk about set are basically the unique elements. Let's say I have given you lots many in a list. There are lots many names present. So I want you to find the unique ones. What you can use there is the set. So when you will use set, that will give you only the unique names that without any repetition. Okay, so that was about set. Now coming to the sequence step. Okay, now when we talk about string, list or tuple, all these maintain a sequence. Why and how, I'll see you. So when we talk about string, what we do is that what it is all about is a sequence of character. And what list is about, it's basically a list of a list of, let's say, elements. And tuple is the one, let's say, list is always in square brackets and tuples are written in this one, so the first bracket or the simple brackets. Okay, now what is speciality about list are mutable, that is the content inside the list could be changed, but tuples are immutable, that is, let's say, the content inside the tuple could not be changed any further. Okay, now let's see some examples which could give us a better understanding. So here are movie ratings. Let's say 4.5, 3.8, uh, 4.25, 5.0, and 4.8. Now we want to print the movie rating, and as it is stored in the movie rating, we just print the movie rating. How we are printing here is that we are writing a name as movie rating, we are printing this, and we are calling this variable which is differentiated by a comma. This is a way we could print the variable. Okay, and another thing, what we are doing here, we are trying to find the average rating. Now, when we trying to find the average, you could see that we are using a variable in sum. So as I already said you, in Python, there is lots of this, inbuilt functions which could help us in executing this work. Let's say if maybe we are performing certain operation in other language, we may have to write a few lines of code, but in Python, as we have inbuilt function, that really helps. So we could use the sum of this movie rating, and that gives the sum of this entire list, and then divided by the length of the movie rating, that is the number of elements that are present in the list. So this gives the average rating. Okay, that was about list. And trying to look into dictionary, let's say it is a key value pair. What happens here is that user, this is the user one, that person has watched, let's say, few number of movies here. So the value that is assigned against the user one is a list here again. Okay, so it is not necessary then when we are talking about dictionary, the value here has to be a list. It could be a dictionary even, or anything else. Okay, so here we are considering list, but we could also have a other dictionary, assigned against this user one. Okay, so this was about dictionary, and what we are trying to here is print the user, watch history. That is the entire this thing will get printed, and user two watch. That is we are trying to print the data of user two. So this data will get printed. So let's try executing this cell. So if you could see, the user 2 data has got printed, and here we could see the entire data in the dictionary. Okay, now there is something, as we have discussed about tuples. So here delivery coordinates are often kept as tuples. So this is one of the real life example where we use it. Okay. Now let's say product view. We talked about sets. So here is an example of it. So when you talk about sets, there you could see laptop, phone, headphones. There is again repetition of laptop. But when we try to find the put it in sets, that is in the curly braces, what it gives us is that it gives us the unique elements. You will see that laptop here is not repeated once again. Okay, we have only three elements here. Okay, so there is something else that is called type. We could check the data type of a particular value using this type function. So in the variable x, we are storing 10 and we are trying to find it type, data type. Okay, similarly for this and for this. Okay, let's try executing the cell. So it says that class int. Okay, so the type of this is class int. That means it belongs to the class of integer. And other one says as it is a float value, so it gives us class float, and same for the complex number. Okay, and that's it for the the numeric data types. Okay, now coming to boolean, when we try to find the data type of true and false, it gives us class as bool, which is a boolean data type. Now when we come to string, as I was discussing just before, if you could remember, strings can be written in strings are the sequence of the characters basically. So what we have here is that we could write string in various different form. We could write it in single quotes, we could write it in double quotes, and if we have to write it in multiple lines, we could use triple quotes even. And if we try to print it, we get it here in this way. Okay, and if we want to check the type, yes, all these types are belong to string. Okay, then there is something little different that we have discussed till now. This is, let's say, I want to print something that has, a numeric character in it. That is a statement, but it has a numeric character in it. So here, what it says that I'm trying to print something. I am 0 years old. So this 0 is a numeric value or an integer value. So if I want to print something like this, what we have to do is use commas here. We have to, we are keeping this separate, like inverted comma start and end here. There is a comma, 0, then comma again, then inverted commas. Okay, this is one thing. And then we could do this similar thing in other way. Let's say we have a equals to 55 and we are trying to print it, so we could use f string. Now f string, what it does is that we have added f here and I'm trying to print I am Ishita, and what is there is curly braces, and inside that I'm storing the value a. What this will do, this will print I am Ishita, and it will give us 55 after that, the value stored in a. Is it necessary to use a variable? No, we could simply write 55 if we don't have a variable. This will give the same answer like this. So if you have to add numbers in statement, you could do this using f string. So there is something else again, if else. Okay, now let's take a real life example. So let's say the we could understand it like that. Let's say if it is raining, what I decide is to I'll stay home, or else if it is not raining, so else part remains like unsaid. If it is understood, if this is not there, if it's not raining, then the else part will execute, and what it says that I'll go to office. So under the else part, I could say that I could office. Here I have taken an example of traffic lights, you could say. So what it's doing is that here we have given signal a value of, let's say, red. So when what we are doing here, we are checking that the variable signal is it equals to green. So if it is green, then you will say you can go. If the signal is yellow, we will say be ready to go. And else, if these two conditions are not true, then what will happen? Then this will print stop, do not move. Let's try this executing this. So as signal is red, what it executes, this true becomes false, and we simply execute this. This was about if else. Okay. Now let's come to for loop. So for loop, what happens is that a for loop is used for iterating over sequence of data. Okay. So here what we have is something like a variable fruit which has a list of fruit name listed here. Okay. So what we are doing here is for fruit. That means we are targeting each values in the list here. Okay. And in fruits, that is this variable, and we are targeting each fruits here. So that's why we are writing for fruit in fruits, and we are trying to print I like fruit. That means the specific fruit that is being targeted here, let's say apple. Then when it moves to next, it will print I like banana. Then it will print I like mango. Then it will print I like orange. So this way, the for loop iterates and executes the task which has been assigned to it. Okay, so that was about for loop. Now moving next, what happens is while loop. So while loop, it executes until the condition that we are writing here is true, and it executes the remaining process that we have written here. So what we are doing, we are taking a variable, let's say count, and we are assigning it a value, let's say 5. So what we do here is that while count is greater than 0, this function will execute. What it says, let's see. So it will print countdown and the count. For the first instance, when we will see, the count is 5. Later on, what it is doing, if you could see, count minus equals 1. So this is simply same as count equals to count minus 1. Okay, so it's reducing the value of count by 1. So when again it will check is the count value, it is reduced to 4 now. When it goes to while loop, again it check is my value of count is now 4. Again it check is it greater than 0? Yes, it's greater than 0. So this while loop will execute. So it prints countdown 4. Similarly for 3, similarly for 2, and similarly for 1. Now that it has printed 1, this will again reduce by 1 and will turn to 0. Now when we go and check, is our count value greater than 0? It returns false and the loop breaks. So this code will not be read further. Okay, so that's about while loop. Now we will discuss about few built-in functions that Python provides us. So let's look into len, and that has the simple brackets around it. So when we by this we simply means we are trying to check the length of a length of anything. Let's say it could be a list or anything. We have a string here. So in the variable name we are simply storing Python, and what else we are doing is we are trying to print the length of the name, that is Python. So it returns us a value 6. Now moving next, what do we have is that max and min. We could also count the max and min value of this. How can we do it? So we have a list of numbers storing in nums. We try to print the max of num. So it will give the maximum value from this from this list. So what is the maximum value? The maximum value is 9. And what is the minimum value from this list? That gives you 1. So these are the few inbuilt functions that we have in Python. And we also have for sum, that is what it do is it simply calculates the sum of this entire thing. So we have 10 plus 20 plus 30. If we do, we'll get the value as 60. So when we have to implement this, what we could do is simply write the function name. After that, the first bracket or the simple brackets, and we could write the variable name. So then this function will be applicable on this variable, and it will get your answer like this. We have got here. Now, these were some built-in function which Python offers. Now let's speak about the that we can make our own function or not. Yes, we can. So how could we do it? So whenever we are making a function in Python, what we can do is we have to write def. That means we are defining a function. Then we have to give it a name. Let's say I have given here cut an apple. Then I have passed, let's say this is a parameter, and what I am doing is printing a particular statement. Now I am calling this function and um, passing an argument here. So this could be initially a little overwhelming. Let's take the example in a good way. Let's say it can often happen that, let's say, your mother is calling you for doing a particular task. Similarly, this function is being called for doing a particular task. Your mother can give you a fruit. Let's say here it is equals to an apple. And what she can do is that assign you a task, let's say, to cut the apple. And here what we are doing is simply like we are calling the function for executing a particular task. So function are being called now a piece of code for executing a particular task. So when we call this, we pass an argument here. So we pass apple as an argument, and what it takes here in the fruit, it takes the value apple, and when it prints the fruit, the name that we have passed here, that was apple. So what it prints is cut apple, this way. So this is how we could make a function of ours, like by ourselves. So any doubts till here? Can I get a quick yes or no?
No, ma'am.
Okay, great. This was quite basic about Python. Now we will be diving more deep into more by a few Python libraries. Let's say we have NumPy here. Okay. So now what is NumPy? Yes, somebody is saying something.
Ma'am, in print statement, why have we written F?
You are talking about this this one?
To handle the large data set.
Which one are you talking about? Are you talking about cell number 9?
I'm just talking about why we write small f inside the print statement.
Yes, that what I said here, this is basically an F string. Okay, let me repeat it. What is a F string? So F string we use only when, let's say, we have to pass a different data type into like this statement. What we are passing here, if you could see, that is 55. Or let's say we were passing A. Okay, now if it simply printed without this curly braces and this F string, this F, let's see what it prints. It will print only this. It will print I am Ishita, then it will print A. But we don't want that. We want to pass this value inside it. For this kind of cases, we use F string. So whenever we are using this F string stands for formatted string. So in that case, what we will use is that we will use curly braces here. And what difference you will see it makes is that it prints I am Ishita, and after that it prints 55. So is it clear now?
Yes, ma'am.
Okay, great. Now let's talk about a library in Python which at times is used for data analysis. which is NumPy. Now, what is NumPy? So, NumPy stands for Numerical Python. It is a fundamental library for numerical computing in Python and provides a powerful n-dimensional array objects and functions for performing mathematical operation on these array, forming basics for many other data analysis libraries. Okay. Now, what happens is that the main thing which you will be noticing here, whenever we are using any library, what we have to do is import the library. So this statement is at must. If we remove this, this will not execute. Let's try, you could see that it's not executing. So this we have to make sure that we are importing the NumPy library in order to execute this cell. Okay, so what does import means? If in plain words I say you, let's say if you have to use something, you need to have that before you use it. If you don't have something, how can you use this? Okay, so by import we are doing is that we are bringing it to our file so that we could use that thing in our piece of code in that particular file. Okay, so we are importing NumPy as NP. So we all must be having some or either nicknames. If somebody doesn't have, that's completely okay. But what so simply we are giving it a nickname. Let's say NP, and throughout you will see that we are using NP instead of NumPy, and we are executing this piece of code. Now, what NumPy array has to do is we have a variable again ARR, and what we are doing is that we are storing an NumPy dot array. That means we are saying it is an NumPy array, and what we are passing there is a list of numbers. Okay, and we try to print this variable. It gives you this list, and if you now try to check check the type of this, it will give you it is of numpy.nd array. uh, uh, that is the type. Now, why nd array? Nd array stands for n dimensional array. So what in NumPy you will see that we deal with it can be a matrix of data that could have n dimensional array. It could be 1D, 2D, 3D, anything. Okay, so why NumPy? If you
Ma'am,
see quite, yes.
how it is different than a list and a tuple?
Yes, right. Coming to that, tuple is quite different, brother. The tuple, what if you have seen the syntax? Let me go to the let me explain by writing. In when you see tuple, what you have is like, let's say 1, 2. This is a tuple, okay. But when you have a list, what do we have? Let's say my name. Then you can have another name, but you can have a number as well. 1, 2, 3. This is a list. Okay, so this is different. List is mutable and tuples are immutable. So that means we could access this numbers and we could change it. But in tuples, that is not possible. So that there is a difference between tuple and list. Now coming to the question that how it is different from how this list is different from NumPy array. Okay, so if initially we'll look into the the thing, it may seems to be similar, but it is not. What is that? Like, why we should use NumPy array instead of list? Okay, so what happens that when you use NumPy, like it is actually written in C. So the in back, or like the back operations are written in C. So what happens is that it makes it more faster than the Python list. As you could see here, the first point is it is faster. Now coming to the point is memory efficient. So NumPy array stores data in stores data more compactly than list. So that makes it memory efficient. Now, when you work with NumPy arrays, so it could be, as I already said you, it could be multi-dimensional array. So for mathematical operation, that could be a better choice. So have I answered your question? What is your name, by the way? Somebody just asked me the difference between.
My name is Dheeraj.
Okay, so your question is answered, hopefully.
Yes, ma'am. Partially, I can say. Later, I will discuss.
Okay, fine. Let's move forward then. Okay, so you can see basically when we run the cells now, we could import it only once, that would work. So, but at times you could spot it, this import statement again and again, because I sometimes copy it from the website. So yes, just ignore the import statement, and it would still execute it because we have already run this cell before. Okay, so what we are doing here is that again, we are trying to, like I just told you about the mathematical operations here. So what we are trying to do here is that we are initializing a NumPy array as this. And what we are trying to do here is multiply the entire array into 2. So what happens here? We could see a result that is multiplied with 2. So it is 2, 4, and 6, which was 1, 2, 3 is multiplied by 2 now. So that's how it helps. Okay. Then what this says is that this we could see a two-dimensional array. We have 2 rows and 3 columns here. Now we have few operations here like flatten. What does flatten is used for? There, to be very honest, there are plenty of functions like this which we could use, and we use during a data analysis. Okay, so but we will be discussing few only now. Let's say the first one is flatten. We at times we try to flatten the array. So it is a two-dimensional array, and we will be trying to convert it into one-dimensional array. So when we flatten this, it looks something like this. That is, there was 2 rows, it has been changed into a single row now. Okay, that was about flatten. Moving next, we have reshape. So this is a 1D array. We could see it is a 1D array. And here what we are saying is that we are initializing the number of rows and columns. So we have initialized the number of rows as 2 and columns as 3. So when we do that, we get it as something like this. So which has, with the function reshape, we get it something like this, which has 3 rows and 2 columns. Okay, that was about reshape. Moving next, we could also calculate the mean value of an NumPy array. Okay, so this is the entire array. Now, when we try to calculate the mean, we could simply use this function mean on this variable to calculate the mean. Okay, so you could see that this gives us the result as a 3.0. So this is how we could calculate the mean. And by the way, it is in float format. Okay, so that was about in quite a brief about NumPy array. There is lots many things to explore, and let's for now start with pandas. Okay, so just like the NumPy that is used for mostly mathematical operations, let's talk about pandas. So what are pandas? Pandas is a Python library that is built on top of NumPy. Pandas is a go-to library for data manipulation and analysis with structured data. It introduces data frame, a tabular data structure that specifies tasks like data cleaning, transformation, aggregation, and handling missing data. Okay, so let's say we have a CSV file. Okay, now we are uploading it. So how we are going to read it, how we are going to work with it. So with all these things, pandas helps us. What it does basically is create data frames. We will come to know about what is data frame and all. So let's start about there is the term series. So what is series? Series is like a single column of data. Okay, it has values and it has index, or you could say rows label, and it is a one dimensional, something like this. So what, how to like import pandas, just the same as we do for NumPy, import pandas as PD. We assign it a nickname that we are going to use throughout the piece of code. So what we are doing is that we are taking a variable, and we are taking pd dot series. So we are making it into series. This list is converted to series, and we are trying to print s now. So what it gives us, it gives us the numbers with a certain indexing. Okay, so that's how it works. And coming to data frames that I was talking about, data frame is a kind of table like structure, like an Excel sheet that has rows and columns. And what you could see is that each column here is a series, like it has an indexed value that is from 0 to the n number of rows that are present here. So something like this. Now the data set here, we have used a sample data set content here. So whenever you are working in Colab, this is Google Colab, and whenever you are working in this kind of environment, what you have to do is, let's say we have to upload our data set here. What we could do is simply type for our data set and then upload it. So you could see that this is here, I've already uploaded, and we could simply copy the path and paste it here as I have done. Okay, and then we could work with this file. Okay, what we are doing here is importing pandas, and this df, we are assigning it a variable df, and we are trying to read the csv file that we have uploaded. Okay, so the this is the file path which I have already said you, which we have pasted here. And what does df head means? So we are trying to see the data frame from the head, that means from the top. Okay, so this has a default value of 4. We could even try
Hello.
it with, yes, somebody speaking. Yes, any questions?
No, ma'am, you may continue.
Okay, fine. So this is how it works. Now let's give a specific number. Let's say 5. It's 5 is already there. Let's try with 6 now. So you could see that the number of rows has increased. So inside this head, if we write whatever number we write, what happens is that that number of rows we could see. There is another function called tail, which starts from the downwards. Okay, like head, it's from upwards, and tail is from downwards. Now we could also see the number of columns. We could see the columns by df columns. Okay, so we could see it this way. The columns will be visible, and we could access a particular field. Let's say we have name here, and we want to see the names here. So we could list it in this way. Okay, now there is a condition. So let's say a condition. What we are trying to do here, we are trying to extract the records with where salary is greater than 60,000. So these
Excuse
are
me,
the
ma'am.
records. Yes.
So these name, age, and salary department, all things are already defined in the Excel sheet. Then after it's ready,
Yes. Yes, they are
and
there. What?
indexing it is providing by itself.
Yes. Yes. If you could see that our if I could show you the data set, just give me a minute. I hope it's there. Okay. This is we I have I'm taking into account only a very small data set. We usually work with lots of millions and millions of data with many rows. So this is what it looks like. So if you see this here, indexing starts with 0, and these are the columns that is additionally added here, and these are the this one is was previously present. Okay, I hope your question is answered. Doubts are
Yes,
clear.
ma'am. So is it also does it also work with the when we prepare our file in the text?
Um, text, you have to convert it into CSV format, or you have to convert it into a data frame format. Then only we can do indexing.
Okay. Yes.
Okay. Now let's
Excuse me, ma'am.
try. Yes.
Could you please tell me the difference between pandas and NumPy?
Yes. Okay. So what we do basically do, if you go by the definition which I was discussing here, what you will see that pandas are basically built on top of NumPy. Okay. So what when we usually do data analysis, let's say manipulation, and what we are trying to do here, if you see, we have a particular data set, and we are trying to analyze the data by seeing, let's say, by each column, or we could see, drop the NA values. Let's say there are null values, take out the mean, and the analysis process which we do basically are done by pandas. And when we use NumPy are mostly used for the mathematical operations. Is your question answered?
Yes, ma'am.
Okay, let's move forward. I will go a little fast. Just tell me if you don't understand. Okay, so this is a condition. What we are checking here, the salary width where it is more than 60,000. So the values, the rows which you could see here, here all the values have the salary more than 60,000. Okay, now this is a command which is not executable here because we don't have a missing value. So this will remove the column with the missing value. So we could simply write it as df, which is a variable which we have assigned it, drop na. So by this function it will drop the missing values. Now we could also rename the columns. Let's say we are renaming the column. Somebody
Sorry to
saying,
interrupt, Ishita. You can wrap up your session. No worries. Okay, no need to hurry. Okay.
okay ma'am,
Okay.
fine.
You can take more 5 or 10 minutes. Okay, extra.
Okay ma'am, fine.
Okay.
Okay, so what we are doing here is that we are, renaming it. Let's say we were having, if you could see, we were having the, name as salary, and what we are trying to do here is we are trying to rename it with income. Okay, and we have an in place true. Now, what this in place true means? We are, let's say, we have a data set. Now, when we are doing in place as true, that means our actual data set which we have here, this changes will be reflected to those only. But when we are doing in place false, it will not be reflected in our actual data set, and our actual data set will stay intact. Okay, so let's moving further. There is a library, called Matplotlib, so which is basically used for data visualization. Okay, so a comprehensive library for creating static and animated interactive visualization in Python. Okay, so what we are doing here, just like pandas and all, we are importing Matplotlib pyplot as PLT, again giving it a nickname as we have given here. We are reading the same CSV file here. So yes, we could skip this as well, as we have already done it before. So let's first talk about a line plot. So what we are doing here is plt dot plot. We are trying to plot it, and what we are doing is df dot index. We are doing df salary. That means we are accessing the column salary here. Okay, so we are trying to plot the salary and the employer's index. That means if you have seen here, we have index value 0, 1, 2, 3. We are referring to those index here. So this is 0, 1, 2, 3 are the employees index here. Okay, so what we are giving it a title. The plt dot title will give it a title. Let's say salary trend here. Then x dot label, we could give it a label in the x-axis, that is employee index. Then we could write it as y dot label as salary. So there in the y-axis we have salary. Okay, now grids, if we want to keep grids, we could write it as true, and let's make it false and check how it looks. It looks good, or like as per your preference, if you feel it's easier without it. So this shows an error, plt is not defined. Okay, I'm not on the cell. Now it should work. Yes, so this gives us a plot without grids, because grids have written it as false. The PLT show will show us the plot. Okay, now let's move to the bar chart. In bar chart, again we have two values here. We are having department, and as we have specified here, we need salary, so we are having two this columns here. Or if we would haven't written it, it would have taken this one, the index value, the so as it was taking in this case. So yes, then we are giving it a title here. Let's say salary by department, and x is which column will be there, y x is which column will be there. Again, grid is true, and again, PLT show. That means it will show us the plot. Okay, and what we can do is there, we will see the trend, how it's changing. Okay, and let's come to the next one, which is a scatter plot. What happens here is that we are taking again two columns, let's say age and salary, and we are assigning it a title. Again, what will be there in x-axis, y-axis, and grid as true, and again show. So what happens is there, here is that again it is trying to plot the value like against the age and the salary with a dot, and you could see that it is scattered here and there. That's why usually it's called as scatter plot. Okay, now let's concentrate to this. So here something new comes to us, that is legends. So what are legends? Basically, it gives you information about, let's say we have two lines here. One shows you this employee, this one employee salary and employee age here. So legends usually are used to give, show what does these lines, mean here. That's why we can use legends here, and other everything else remains mostly the same. Again, title, x label, y label, and we are trying to show the plot. And here we also have grid, so it is simply the same. So now this we also have, we could add more precision to it. Like we could say this is not from the data set, this is values which I have assigned to it. So I'm trying to plot these values, and I have a line style. I'm telling it, my line should look something like this, which is a dotted line, and I need a marker which marks it as O, and its color should be red. So this is how it's look. If let's make how it looks, if it is blue. So this is how things change. Okay, let's look into the last one, that is seaborn. Seaborn is kind
Excuse
of,
me, ma'am.
yes,
So is this marker is already specified at the hinges, or we can specify specifically at a certain point?
didn't get you. Please come again.
See, here the marker is like O marker is given at 3 points at 110, and somewhere at the 220, and the other is at 315 something, isn't it?
Okay. Yes. So let me answer your questions. These markers are coming against this point. So let's say 1 for 10, and 2 for 20, and 3 for 15, something like that. These are the points that you could see that there are three marking points. So when we plot x-axis against y-axis, so these values are the ones where these points are the one where these values intersect with each other. Okay, so that's why we get this markers. Is your question answered?
Yes, ma'am.
Okay, let's go further. We have something called as seaborn. So what is seaborn? Seaborn is kind of, an advanced version of uh, Matplotlib, which gives us quite benefits over. It has a good wide thematic view, if you could see. So when we try to see this, this is a histogram. So when we use names like his plot, and this looks visually quite attractive rather than the matplotlib, if you could see. And similarly, if you could see for this, these are the box plot. When you name in the further in the internship, we will discuss about these box plot and wait, you may find it quite overwhelming. What are these? We have maximum median value, outliers here, and so many things more. Okay, so what is a scatter plot like the one we have seen in the matplot? This looks a little bit visually attractive, and we could add more, personalization to it. Okay, so this one is the line plot, and again we have an histogram here, and this is a heat map. So here we don't have quite lots of values, otherwise it looks really very attractive. So saying quite about heat map, it takes in only the numerical values, the value with the columns with the numerical values, and the red ones here shows us the positive correlation, where one column is related to the other in a positive way, and the blue one shows negative correlation, that is they are negatively correlated. That means one will decrease, other will increase. So something like that. This was in brief about the analytical tools, the libraries which we use, and quite basic about Python. So here it's all. Any doubts? Any doubts? Is
No, ma'am.
everything clear?
Yes.
Okay, that's it all from my side. Thank you for being patient listener. Okay,
Thank you so
bye
much,
then.
ma'am.
Okay, thank you so much, Ishita ma'am. And thank you so much, everyone, for being so interactive with our mentor and asking the doubts and everything. So, before beginning our next session, let me just. Oh, just a sec. Okay. So before moving on further to our next session, let me introduce you to our next topic, which will be from data to decision, understanding the machine learning in real world. And this will be all a conceptual and practical walkthrough of how machine learning solves everyday problems. So it will be taught to you by Dr. Shafila. She is a manager learning at Sabudh Foundation. So let me just welcome ma'am. Over to you, ma'am.
Thank you, Rakshita. So, hi everyone. I'm just sharing my screen. I hope my screen is visible.
Yes, ma'am.
Thank you. So, are we recording the session, Rakshita?
Yes, ma'am.
Okay. Okay, so let's start with the topic. So, for me, the topic is understanding machine learning. Understanding machine learning in the real world. So, basically, in the next 1 hour, or I would say next 50 minutes, we will explore how machine learning is used in your real life. Okay. And I hope by the end, whether it is, Netflix, or it is health sector, or it is, the business sector. So I hope after 1 hour, you will be able to see that machine learning is all around us. It is actually shaping our daily life. So we will understand the concepts like regression. We will understand the concepts like classification, prediction, clustering. So through the real examples only. I will not be going through the coding. I will not be going through the core concepts. But yes, we will try to understand these concepts, which are the foundation of machine learning, through the real examples. So let me start with a small story. So how machine learning is actually shaping our future or shaping our day-to-day life. So the story starts like, there is a small vendor, the owner of a cafe, who actually bakes the cakes. And what he observe is, like, when he is baking more, he normally, it leads to the wasting of food. When he is baking less, then he loses the customers. So basically, he is not able to decide how much cakes he shall bake. So with the time, he just start noting the patterns. What patterns? He start noting the day of the month, he start noting the weather, and he start noting the sales of the month. So basically, when I am saying this is basically these are my input data. He start noting these factors. So when he start noting these factors, he is then able to take the decision on what day of the month, whether the weekday or weekend, how much cake I shall bake so that neither I lose the customer, nor I waste the food. So as soon as he started noting this kind of pattern, he is in a position to take the decision. So this is basically machine learning is. So this is how the machine learning work. Machine learning, it works. You are giving the data, and using that data, it start learning from the pattern, and using those pattern, it gives you the you are in a position to take the decisions. So this is I hope this example, it give you a gist of what machine learning is. So before I move ahead, I would like everyone to type in the chat, or you can just raise your hand or unmute yourself. So how many of you have experienced about YouTube or Netflix recommendations? You can type in the chat also. Okay. Okay. Yes, everybody actually. Right. And how many of you have seen on your LinkedIn people you may know? How many of you have seen that? Right. Okay. Yes. And also, if I talk about Instagram, so how many of you have seen that? Suppose I am taking the name of Rakshita. Rakshita is on Instagram. You may like to follow her. So this also we see, right? So actually, these are actually the real life examples of machine learning, where the machines are learning patterns through the data. So also, I think everybody, all of us basically, we check our Google Maps before we leave from house, before we leave for our office or our college, because we want to see which road I shall take to avoid the traffic. So these all are basically are the micro decisions which are taken using the data by the machine learning, not through the human logic. So these are the examples of where machine learning is working behind in real life. So when we are discussing the example of Netflix obviously it recommend you the shows, the web series or movies based on your viewing history. So when I am giving the example of Netflix, it is actually the perfect example of, I would say, classification and prediction. So basically, it classifies, Netflix is having a richer user behavior segment. So it classify it give you the personalized recommendation, predict the personalized thing for you. So basically, it classify the shows according to your watched history, whether you are interested in which genre, you are interested in action movies, you are interested in the romantic movies. So on the basis of that, it classifies the shows according to your interest, and then it predicts. So when I am saying the example of Google Map and travel time, so basically because it is giving you, when you are just checking your Google Map, it is giving you, okay, to reach office, it will take you 35 minutes. So it is giving you a value, a number, a numerical value. So this is an example of regression I will be coming on what is classification and what is regression and what is prediction. So we will be coming on this also. So second, the Google map, when it is predicting travel time for you, it is an example of regression and it is taking into consideration time series. Time series machine learning model. So when your data is related to the time. Okay. So also Spotify, it curate the playlist for you. Spotify also, Netflix and Spotify, basically Netflix also works on clusterings, but majorly it works on classification, and Spotify, it majorly works on clustering and also on the similarity models. We will not be discussing what is similarity model, but yes, when you are in the internship, these topics will be taught you, thoroughly. So clustering is an example of unsupervised machine learning. We will be discussing that also. So basically, Spotify curate a playlist for you on the basis of clusters. So this is these are the songs of 90s, these are the songs of 80s, these are the songs from Arijit, these are the songs from Sonu Nigam. So this is how it curate the playlist for you through the clustering. And similarity models, it again see the watch history, what kind of songs you are listening to. So on the basis of that, it is just giving you the recommendation, or it is curating a playlist for you. So these are the examples, the very few examples I have given. But yes, everywhere in your real life, you will see everywhere is the data. And in today's life, everything is revolving around data science or machine learning. Okay. So when I'm saying what is machine learning is actually when you are teaching computers or machines to learn patterns from the data, and on the basis of the patterns of the data, you are able to take the decisions. So this is what machine learning is. And in machine learning, you are not programming the computers, you are not programming the algos step by step. This is how you do in the traditional programming. What we do in the traditional programming, if I just write it here. So in traditional programming, what we do is we give the rules, we give the data, and what we want is output. So let me give you an example. The rule is, please take the square of this is my data, take the square of my data and give me the output. So you have given the program that 2 is my data. I want to take the square of 2. It will give you output as 4. But machine learning doesn't work like this. In machine learning, actually, what you do is you give the data and you give the output. You want to use a machine learning model which will provide you a rule. So basically, my data is 2. I want it shall give me an output as 4. On the basis of that, it will give you a rule that this is how you will be able to get output as is equal to 4. So machine learning, basically, it give you rule instead of giving you the output. So this is how your when I'm saying the rule, actually in machine learning, this rule is machine learning model. So you have made a simple machine learning model by this example. 2 is my data, output is my 4, and rule is, this is my machine learning model. So my first machine learning model is 2 square. So this is how machine learning works. So I just discussed about supervised learning, unsupervised learning. I have just given you the names. And we have not discussed these things. I will be discussing these things when we are going ahead with the session. Okay, so let's take another example. The very common example you must have noticed in your email inbox. So few emails are written as spam, few emails are written as inbox. So there is a label called social. So basically, these are the filtration of the emails. So when you are filtering the emails, So this is on the behind of these filtering of the emails. We have machine learning models which learn patterns from the data. What data is provided to these ML models? So data is the text in your email. So suppose you have an email with the subject lottery, so it will be going to spam. So you have a subject of email alert, again it will be going to spam. So this is how it is filtering your emails, whether it will go to spam or it is a ham. So when I am giving you example of filtering whether it is spam or ham, so basically what I am doing is I am classifying. So this is very classification problem. So classification problem is when you are classifying your email into spam or ham. And in my previous example, when I said the ETA in Google Map. So ETA in Google Map, it was 35 minutes. So because it is not a classification, it is not giving me the categories, it is giving me a numerical value. So this is an example of regression. So when I am saying regression, when I am saying classification, both are the examples of supervised machine learning models. Supervised learning. So basically, machine learning, when we discuss about machine learning, the most two important learnings are supervised and unsupervised. So these are the types of machine learning models. Supervised is when your model is learning from the output, but the output is labeled. The output is labeled. So I just gave you an example. 2 is my data, 4 is my output. This is the rule that ML has given me, and this is your output when your output is labeled. So that is an example of supervised learning. Labeled means you already know the correct answer. You know the labels, you already know the correct answers. Then you have millions of an examples. So this is one example. 2 plus 4, yeah, 2 is my data, 4 is my output, and it is giving me this rule. So it could be 3 comma, it could be 9, again it is giving you 3 square, 4 comma 16. So that is how million of data suppose you have. So by using this data, and these all are the labeled output, when you are giving a machine learning model a labeled output and it is learning pattern from the labeled output, that is an example of supervised learning. When you are not giving a labeled output, output is there but it is unlabeled, you don't know the correct answer, so that is an example of unsupervised learning. So for example, the common example that I normally give, you have different balls. So you are giving a kid different type of balls. Suppose 20 balls are here. So one ball is of this size or this shape, another ball is of this size or this shape, another ball is this size of this shape. So you are giving that kid 20 balls and you are asking कि इसका just see the pattern, just just see what you can do with this data. So the immediate the decision or immediate act what the kid will be doing is he will be or she will be segregating the balls, maybe on the basis of size or maybe on the basis of shape. So this is how machine learning is learning from unlabeled data. So you have not labeled the data. Yes, this is a tennis ball. Yes, this is a cricket ball. This is a football. You have not given the labels, but you have just given the data. Then machine learning model will be learning patterns from the data. It will be dividing or it will be segregating your data in different clusters. On the basis of those, it will be just giving you the decisions or it will be giving you the predictions, whatever you want. Okay, so this is an example. This is just an overview of what is supervised and what is unsupervised machine learning. And in the supervised, these are the types of machine learning models. And when we are saying about classification or when we are saying about regression, so both are the examples of supervised machine learning model. So basically these are the task of supervised machine learning models. Any questions still here? Any questions still here?
No, ma'am.
Okay, thank you. So this is what I have written is how machine learning works. So basically, this is the whole pipeline in machine learning model. This is how any of your machine learning model works. So first of all, you collect the data. Okay, so when I'm saying you collect the data, for example, you are from a business, from a e-commerce, business, and when I'm saying e-commerce business, suppose you are working, or you are an so I am just dealing with e-commerce site or website. So any e-commerce site or website, it is actually collecting your data. When I am saying data means data could be your likes, data could be your views, data could be, see, everywhere on internet you are leaving your data. Whether you are scrolling something, or you are viewing something, or you are liking something, or you are giving some comments, or you are uploading something, so that is actually data. So e-commerce, when I'm saying data collection, so how e-commerce websites are collecting your data through the views, through whether you have logged in to their website, you have put something in the cart, so this is how the data is collected. So first of all, the data is collected. Second is we are cleaning, or we are preparing our data. So this is the most important thing. So when we are saying we are cleaning or preparing our data, actually here we are dealing with, we are handling the missing value, or we are handling with the outliers. Ishita ma'am just touched upon these things. What is missing value or what is outliers? Outliers means she just shown you the box plot. So this is my box plot, and mostly my data lies here, or it could be here, but there are certain values which are lying here. So these could be outliers. So I may not need this point or this data point in my data, because it could lead me, it could mislead the result. But it again depend upon data scientist to data scientist, or person to person, whether they want to consider this particular data as outlier or not. It depend upon the problem statement also. Suppose my problem statement is age of the people, and in my data maximum people are having age from 9 to 20, but there are few, very few, or I could say, suppose my data is having 1,000 data points, and out of 1,000, 990 are having age between 9 to 20, or 999 are having age between 9 to 20, but one person is having age 89. I cannot say 89 is outlier, because there is a possibility that age is 89. So again, it depends upon you whether you want to consider that particular data point as outlier or not. Missing value. Missing value means you have to predict, you are predicting something where the age is very important factor, but out of 1,000 data points, for 700 or for 500 data points, you don't have age value, but age is something which is very important. So what you will do, so you have to handle the missing value. Either, see, half of my data is not having that value, so in that case we have to think whether we are whether we are imputing the missing value with some the average thing or median, or we will be just dropping that factor. So you have to decide this thing. It again depend upon your problem statement and your goal also. So this is what I am meant to say, data cleaning and preparation. Then the third step is feature selection. Feature selection is, you are suppose age is one factor. When I am saying factor, I am just saying the feature. So in machine learning, factor and feature, they are interchangeably, we use it. So let me give you another scenario. So this is how Ishita ma'am just shown you a data frame. Okay. When I give you analogy about input, this is my data basically. Then I write the output. This is my rule. So when I'm saying output, now this is basically my target. In machine learning, we do call output as target. We call input as features. And suppose these all are my features. And I am expressing my features as capital X and my target as Y. So you may have heard this equation, equation of a line, y is equal to mx plus c. I will not go into detail. It will be overwhelming for you. But yes, y is my target. This is my target, which I already know. So for my previous example, 2 plus 4 or 2 comma 4 is equal to 2 square. So this is my value, first value, 2, 3, 4, 5. And what is my target? 4, 9, 16, 25. So this is one example. Suppose I am not dealing with this numerical data. I have another data, and example is, the problem statement is very common problem statement, that is house price prediction. So when I'm saying house price prediction, means what you have to predict, what will be the house price. So what I have the number of floors in the house. I have whether the house is on, it is a corner house or not, whether there is market around it or not, whether it is 2 BHK or 3 BHK. So these all are actually my features. And on the basis of this is, you have historical data. So suppose there are 2 floors there, the house is the market is, yes, there is a market, and yes, it is 2 BHK. So on the basis of that, you have certain price. Suppose the house price is 65 lakh. So similarly, the floor are 3 floors are there. There is, yes, market. No, it is not 2 BHK, but it is 3 BHK. Okay? Or on the basis of that, the price is CR, 1 CR. So this is actually your data is. So when I was saying the input, or I was saying the features. So features, factors, input is actually these values. 2, yes, yes. And what is the output? This is my target. This is my output. And your machine learning model, it learns from this pattern. And whenever you are giving a new data, what is my new data? So my new data is, there are 2 floors there, the house is 2 BHK, there is no market around, there is no hospital around. Okay, just give me the house price, just predict a house price for me. So this is how your machine learning model works. But yes, these are, when I meant to say, what I meant to say when we were discussing feature engineering. See, whether the BHK, 2 BHK or 3 BHK, this is an important factor. Floors in the house, important factor. Market is there or not, important factor. What is the whether there is hospital around, important factor. School around, important factor. What is the wall color in the house? Not at all important. Okay, so there could be some features which are actually not important, or which we feel doesn't much impact the price of the house. So those, though we have to engineer those features, we could remove those features, or we could use certain algos in the direct, algos or direct libraries are there in Python, that you will be directly using, and it will be giving you the important features, just removing the redundant or unwanted features. So suppose you have another problem statement. Now this house price prediction is an example of regression problem. So what problem I am calling as a regression problem? When your output is a numerical value. It could be numerical continuous value. And in house price prediction, it was your numerical and continuous value. So suppose your another problem statement is, you want to decide whether you will be giving loan to a person or not. Yes or no. Actually, it's a classification problem. And in this classification problem, what could be your factors or what could be your input data? My input data is salary of the person, whether it has already certain previous loan or not, how many members are there in the family of that person, what is the qualification of that person, okay, whether he owns a car or not, what is the color of that person, whether he has hair or not, what is the height of that person. So actually these are the factors which are not directly helping me in take the decision whether I shall give the loan to the person or not. Okay, so this is what feature engineering means. You are removing the unwanted feature, so that is feature selection. Then you are
Excuse me,
training.
ma'am.
Yes, Dheeraj.
Uh, Ma'am, let's say I have prepared a machine learning model. Okay, and so I have given the feature 1 2 3. Okay, let's say 1 2 3 is the random thing, and I'm asking the machine learning model about the feature 10, which is not included during the preparation of the model. Then how does the machine learning reacts to that? Let's say I have given like I need some furniture, I need some
See,
floor.
whatever I just understood your question. See, what I have, as a human, okay, as a human, how you will provide a loan to a customer? I will provide you you will interact with the person. You will try to be, see, आप देखोगे कि कितना friendly है वो person. आपका एक human intelligence होता है. You use the human intelligence, and on the basis of that, you are deciding whether you want to provide loan to that person or not. And suppose I have historical data. मेरा historical data क्या है? I have experience of 20 years. Okay, and 20 years के experience में I have met numerous of persons, और सबका अपना अपना किसी का story होएगा. So उसके basis पे, मेरे experience के basis पे, I am just deciding whether I will be giving loan to this person or not. बट कंप्यूटर्स के केस में और मशीन के केस में क्या है? वट एवर यू आर गिविंग द डेटा, इट विल बी ट्रेन्ड ऑन दैट. अगर आप उसको कोई ऐसा फीचर देते हो विच आर नॉट देयर इन द ट्रेनिंग सेट, दिस इज योर क्वेश्चन, so it may not consider that thing because it has 9 other feature to consider and to decide whether this person will be a defaulter or not, whether you will be giving the loan to this person, you shall give the loan to this person or not, because it has another features also. Clear hai?
Yes,
Is it clear?
yes, ma'am. Yes, ma'am.
Okay, thank you.
Excuse me, ma'am.
Yes, please.
Ma'am, is it in our hand to select the features like, or the machine does it
Machine
itself?
does it for us. Machine does it for us.
Like which
So
are useful for
when
us?
Ansh, when you will be there in the internship, we will be just going through the case studies of machine learning, where you have feature engineering selection library. You are directly using that, and you are just giving, I out of these 100 features, I just want 15. सो वो पीछे से कैसे चलती है, दैट वी विल डिस्कस. सो 100 में से इट विल बी गिविंग यू द 15 मोस्ट इंपॉर्टेंट फैक्टर्स और इंपॉर्टेंट फीचर्स फ्रॉम द डेटा, विच विल हेल्प यू टू डिसाइड कि आपको ये लोन देना है या नहीं देना. Have I answered your question,
Yes,
Ansh?
ma'am. Yes, ma'am.
Okay, thank you. So basically, after the feature selection, we are training the model. So see, when I am saying training the model, na, so this is similar, you are training your kids at home. So I am a mother of 2 kids. So अगर ट्रेनिंग क्या है, 10 साल 15 साल हम लोग अपना जो रूम है, वी आर क्लीनिंग आर रूम, वी आर टेकिंग आर, कैसे रूम क्लीन होएगा अगर हम लोग अपना अपना स्टफ उठा लें. ठीक है, so this is how I am training my kids. So kids or model is learning, or we are training the model through examples. So example से ही वो learn करते हैं, कोई hard core आपको code नहीं देना, they will be learning from the examples only. So similarly your models are, we are training your models through examples. So examples क्या है? 2 is my input, 4 is my output. This is one example. 3 is my input, 9 is my output. This is another example. So this is how you are training the machine learning model. Okay. So then after the training, we are predicting. Your model is giving you predictions. So after the prediction, you have last step, that is the evaluation. You are now evaluating the prediction that your model has given. So you are seeing the accuracy of the model. So suppose you have your data points are 1000, which is actually less data points. ठीक है, मॉडल को ट्रेन करने के लिए वी नीड कि मैक्सिमम से मैक्सिमम आप अपना डेटा दो. एंड यस, डेटा आपका क्लीन होना इज वेरी इंपॉर्टेंट. एंड first you will see the accuracy. Suppose after the accuracy of my model is only 50%. So 50% accuracy means 50% it is giving me the wrong result, 50% it is giving me the right result. तो मैं machine learning model पे why would I trust? So suppose another you have accuracy around 90%. Again, why 10% is wrong? So in Sabudh Foundation, what we do is when people are there in the internship, we auto grade the courseworks. We have numerous तो नहीं बोलूंगी, at least when you are in data science stream, so we will be providing you at least 30 to 40 courseworks in the course of 6 months. So उनको manually check नहीं करते हैं, we do auto grade. And auto grade में if I have 400 courseworks, out of 400 courseworks, suppose 2 coursework का it is giving me 0 score. So that means 98% ये correct है. But why this 0 score to those people? उनके लिए तो ये justified नहीं है ना जिनको 0 score आया है. So again accuracy matter करती है. I don't say कि accuracy shall be 100%. That is also we are doubting our model because 100% कुछ भी correct नहीं होता. Why? Again coming to your question, I think it was Dheeraj only. So Dheeraj, चाहे मैं auto grade कर रही हूँ, कुछ भी कर रही हूँ. So even if I am as a human also, we may be wrong in some situations. So 100% कोई correct नहीं हो सकता. Suppose my problem statement is again house price prediction, and I have taken 20 factors into consideration. So there could be few factors which I have not taken into consideration, but they are actually impacting the house price. So that is how I said कि 100% correct कुछ भी नहीं होता. So accuracy is one thing. So no, mostly we don't only rely on accuracy. There are another metrics also. There could be for the regression, we would say root mean square error. So these are certain matrices that we rely on to evaluate whether your model is working fine or not. But yes, this is how your machine learning model works. So let me give you an example
Excuse me,
about, yes.
but in overfitting the accuracy is also high, na?
So when you are, very nice question, thank you Ansh. When you are saying overfitting, so overfitting क्या है? When your model is giving you 100% accuracy on the test data and it is giving you the less accuracy on the training data. है ना? So what does overfitting means? Although I was not supposed to cover this thing, but yes, I will be doing it. Overfitting is your model has learned the test data so accurately that it is not able to give you the best result for the test data. See, what does machine learning training data, machine learning model training means? Why we are training a machine learning model? We are training a machine learning model on the seen data. When I'm saying seen data, on the test data, so that you are able to take decision on unseen data. When I'm saying this is my training data. So when I'm saying unseen data, I mean to say test data. ठीक है, आपने मॉडल को ट्रेन करा millions of data पे, that model has seen, so that is the training data. Now you are testing, so iska bhi you will be seeing the what is the accuracy of the test data, of the training data, and you will be seeing what is the accuracy of the test data. If your model is giving you 100% accuracy or 98% accuracy on the training data, But when you are giving the model an unseen data and it is giving you an accuracy of 50%, this is what we call the overfitting. And we don't entertain the overfitting in machine learning, because this is an example where your model has learnt the training data so accurately that it is not able to give you prediction on the unseen data. So मैंने अपने मॉडल को ट्रेन करा कैट की thousands of images पे. इट इज बहुत अच्छे से ये कैट को रिकॉग्नाइज करता है. जब मैंने इसको डॉग दिया, इसने फिर से कहा कि इट इज अ कैट. I don't want that. So this is my training data, and it has learned the training data so well. अच्छे से इसको लर्न करा. So this is 100% accuracy. But जब मैंने इसको ट्रेनिंग टेस्ट डेटा दिया, तब it is not able to give you. So this is an example of overfitting.
Ma'am, is it so like outlier need to be in your training data?
No, actually no. Why we want outliers is something which does not, you think it doesn't belong to your data. It is something which doesn't belong to your data. So suppose, Dheeraj, my problem statement is related to mid-level, I would say, employee of IT sector. उसकी सैलरी, ठीक है. सो मिड लेवल एम्प्लॉय है, आईटी सेक्टर का सैलरी, एंड ही और शी इज बेस्ड आउट ऑफ मोहाली. सो मिड लेवल का है, मोहाली का है. सो द सैलरी रेंज कुड बी 12 LC टू आपका 25 लाख. अब सडनली इसी में मेरे पास एक 1 CR का आ गया पर्सन. सो दिस डेटा इज एक्चुअली आउटलायर. You don't want this outlier in your training set. Is it clear? So when we are saying 100% accuracy on the training set, or when we are saying 75% accuracy on the training set, or 85% accuracy on the training set, so basically actually this is one factor. So your model is learning from most many factors in the input data set. So uske basis pe it is learning कि ठीक है, अगर कोई there is a data, there is a picture of an animal जिसका जो ear है वो pointed है. It could be a rabbit. ठीक है. सो पॉइंटेड है, कितना बड़ा है. सो मेरा कहने का मतलब है, ऐसा नहीं है कि रैबिट के साथ साथ मैं उसको डॉग की भी फोटोज देती जाऊं बीच में, और मेरा जो ट्रेन कर रही हूँ रैबिट के ऊपर, बट आई एम गिविंग द द आउटलायर, वो नहीं है. सो यू आर ऑन रॉन्ग ट्रैक. क्लियर है? आई डोंट मीन टू से कि आपका ट्रेनिंग पे भी 100% आ रहा है और टेस्ट पे भी 100% आ रहा है, दैट मीन्स योर मशीन लर्निंग मॉडल इज रॉन्ग. आई डोंट मेंट दैट. आई जस्ट मेंट दैट कि 100% एक्यूरेट कुछ नहीं होता. इट कुड बी 99.99%, इट कुड बी 99.98%. देयर कुड बी चांसेस कि आपका मॉडल कुछ चीजें मिस कर रहा है. बट वी डोंट वांट कि 100% एक्यूरेसी जहां पे हमने ट्रेन करा है बट टेस्ट पे वो कुछ दे नहीं रहा है. दिन को वो रात बोल रहा है, रात को वो दिन बोल रहा है. दैट वी डोंट वांट. Is it clear?
Yes, ma'am.
Okay, thank you. So when we were discussing this pipeline of machine learning, there is, I just want to discuss this pipeline of machine learning through analogy also. So when we are saying the collecting data, suppose you are cooking something and you are taking the ingredients. Your ingredients for any recipe is actually your data. What is the model? Model is the recipe. What recipe you are following? So recipe is your model. Output is the final dish that you have made. Evaluation is the when you are tasting something, you are tasting the dish and you are saying ki, okay, whether it is tasting good or bad. Feedback is you have given the feedback. Okay, so this is feedback is something. So salt is little, you could put more salt, or this is little spicy. So that the feedback is given so that in future you could make a best recipe. So this is the pipeline of machine learning. And when we are saying the core concepts in machine learning, so the most important factor is the data. So first you have the right data. Second is you are training your model. Then supervised learning, unsupervised, we have just discussed. Regression and classification, we have discussed. These are actually the foundational concepts in machine learning. So when you are clear with these concepts, so that means you have a foundational knowledge of machine learning. So let me discuss more real life case studies of machine learning. When we are saying, I have already discussed the regression example and the classification problem. Another example, suppose you want to say whether a customer of any telecom agency, suppose I am a customer of Airtel, and Airtel would like to see that in the next 1 year, whether I would churn or I would stay to Airtel or not. So this is an example of classification or regression. This is an example of anybody? Are you typing in the chat? No.
Ma'am, I skipped. Can you like repeat?
Okay, so we have an example like you are a customer of Airtel agency, telecom agency, and Airtel would like to see whether you will churn or you will stay. Churn or not churn. Churn means whether you will be sticking to the same company or you will be changing from Airtel to Vodafone or Jio. So this is an example of classification
It's a
or regression.
classification.
Classification problem. ठीक है?
Classification.
Right. So
Classification.
thank you everyone. So I'll just give you I just want everybody to answer in the chat. Which machine learning system impact your daily life more? Okay. Examples are health. In health sector also, machine learning is being used. How machine learning is being used to detect whether a person will be having heart disease in future or not, what will be the glucose level of the person, how much chances are there whether this person will develop cancer in future, what will be the life of that person. Okay, so which ML sector or which ML system impact your daily life most? एग्जाम्पल 3 मैं आपको ऑप्शंस दे रही हूँ. वन इज हेल्थ, वन इज सोशल और एंटरटेनमेंट, एंड थर्ड इज द शॉपिंग. यस, व्हाट डू यू थिंक? आपको health, social. So there is no correct answer obviously. So this was only to see ki are you able to think like ki machine learning, how machine learning is shaping your daily life in the entertainment sector, your daily life in the shopping sector, in your daily life in the health sector. Okay, so this was just a example jo I just wanted to know. Okay, so suppose there is another question. Suppose you have your own data, your own life history data, like you have the habits of yours. The data is your habits, your health, your goals in life. Okay? So suppose you have data of your own. What one decision you would like a machine learning would help you to take better? अपनी ही लाइफ का कौन सा बेटर डिसीजन यू वुड लाइक टू टेक हेल्प ऑफ मशीन लर्निंग टू टेक यूजिंग द योर ओन data, your own history or your own life's data? No, habit, health and goals, actually these are the factors, these are the inputs. So for which this is the data, what one decision you would like to take with the help of machine learning in your life? Drug discovery, okay. Habit, health, actually these are the data. You are not able to understand my question. How healthy I will be? Yes, okay.
Future prediction.
For what? Ankita, for what? Whether you are doing good in your life history, it could be the scores in your examinations also. Okay, it could be these are the 3 examples only, but since we have just gone through what machine learning is, you must have you could be at this stage, you, I think, are now in a state where you can see how machine learning is shaping your daily life. So depending upon, you have the whole data of your life. So what one decision you would like to take, the help of machine learning, with the help of machine learning, to see ki, okay, so I would like to know how much I would score in my semester exams. So this is one example. What habit should I develop to reach my goal? Okay. GDP, kiski GDP? Bad habits for better future. So that means, okay, in shopping we can classify items. Okay, how consistent you are, how long do I live? Yes. Would you like to elaborate this? How long do I live? इसके लिए आपके पास डेटा क्या क्या है? What is my age? What is, my exercise routine? What do I eat? So these factors, basically, if I am giving machine learning models these factors, it can help me actually to predict कि कितना मेरा age होना चाहिए. ठीक है? Another factors obviously would be there. Now I am just stopping sharing. I'll reshare my screen. I would like to show you a small code. Let me know if it is visible or not. So this is an example of linear regression, a small code. So here what I am using is, I am importing pandas that your Ishita ma'am just taught you. Just to see my data frame, I am importing pandas. I am using sklearn. It's a library. When you are here in internship, we will be introducing with this library. I am using regression model. So my regression model is linear regression that I am using here is, this is my data. My data is experience of a person, and my second factor is salary of a person. How many data points are here? Anybody can tell? This is my data. I just draw a picture na, x and y का मैंने एक picture बनाया था. Anybody can answer, or you can type in the chat also. I want to know what are the factors in this data. How many data points are there? What are the factors? What is my target? And how many data points are there? Three things I would like to know from you people. So let me ask one by one. How many data points are there? Who have written 5 now? So that is correct. So how many data points are there? 5. 2 factors, right? Somebody has written. No, one factor is actually there. Experience is my factor. And what is my salary? Salary is actually my target. Okay, so in this data, you have 5 data points. Experience is only one factor, and salary is the target. So what I am doing is I am making a data frame. जो मैंने आपको एक टेबल बना के दिखाया था, that is an example of data frame only. I am using linear regression model, and I am fitting that linear regression model. This is my input variable, that is experience, and this is my labeled output variable, that is salary. On the here, basically, with this I am just training my model. I am training my model to learn the pattern. If the experience is one year, salary would be 30K. If the experience is 2 years, salary would be 40K. If the experience is 3 years, salary would be 50K. So this is how I am just training my model. Now I have given my model an unseen data. Unseen data is, you are giving 6. See, again coming to your question, Dheeraj, you just ask, or Ansh has asked, you just ask about the factor which was unseen. Actually, factor is experience only, but I am in the experience, I am giving the unseen data. Factor is experience only. So I have given the factor experience, but now the experience is actually 6. So अगर उसका 6 years का experience है, what could be the salary? On the basis of that, it will predict 80K would be the salary if person's experience is 6 years. So this is one simple example. So I'll just stop here. So if you have any question, you can please ask, unmute and ask. Yes, Ritu, you have rightly said. Definitely. See, can we predict which disease is more likely to affect us based on our current lifestyle? Definitely. Even your doctors, they take decisions, if you we will be going through decision trees also. So your doctors take the decision of any treatment or line of action of treatment on the basis of that only. Okay, machine learning will catch the pattern for decision. Yes, for prediction, right? Any question? Okay, so thank you everyone. So now you will be having your another section. So reinforcement learning, we have not learned, we have not discussed over here. What reinforcement learning is, you must have heard an example बचपन में चींटी का example, that चींटी जो आपका है, चींटी वो चढ़ रही है, चढ़ते चढ़ते वो गिर जाती है, फिर चढ़ती है वो फिर गिर जाती है, फिर चढ़ती है गिर जाती है. So basically चींटी or ant is learning from experience. So when it is learning from experience, that is reinforcement learning. सो आप फेल होते हो फिर चढ़ते हो, फेल होते हो फिर चढ़ते हो. सो वी विल बी डिस्कसिंग दिस इन द इंटर्नशिप प्रॉपरली. ओके,
Thank you, ma'am.
थैंक यू एवरीवन. Over to you, Rakshita. Thank you.
Thank you so much, ma'am, for such a wonderful session. And thank you, everyone who were cooperative and were cross-questioning and asking the doubts from ma'am. So before Suparna ma'am joins for the next session, if you have any sort of doubts regarding any session or anything, let me just inform you, yes, those who are asking for the recordings afterwards, after completing the workshop, you will get the recordings on EduCollab, that is our learning platform system. And apart from that, the resources will also be provided on EduCollab, but we encourage you all to attend the live session, because when we attend something live, you can question the mentors, you can ask the doubts live, right? There are a few perks of joining the things live, right? So let's just wait for a moment till Suparna ma'am joins the call, and once she joins up, we will be starting with our upcoming session. Those who are mentioning to me privately that EduCollab IDs, yes, EduCollab IDs of few people have been created, and the rest will get their EduCollab IDs by tomorrow. Don't worry, you will get today or either tomorrow. So don't worry, before assessment, you will be getting the EduCollab IDs. Just give me a moment. Let me have a quick check with ma'am.
Ma'am, are you going to share these notes which ma'am are using in the session?
Yes, you will be, Rakshita, you can just speak to Suparna. So everybody, EduClab is our learning platform. Those who have registered for the workshop or those who have registered for the internship, we will be providing EduClab credentials to you. You will get EduClab credentials over your email only. Most of you must have received. Those who have not received, you will be getting it. In tomorrow's session, we will let you know how to access those credentials and how to access the LMS. ठीक है, उसमें when you are there, when you are logging into your EduClab, we will show you from where you will be getting the resources and from where you will be getting the access to the recordings. Each and every session today or tomorrow will be getting recorded and it will be uploaded on EduClab. Okay, so don't worry about that. We will be communicating each and every information over your registered email, and yes, the same will be sent to the WhatsApp group also, and it is not mandatory for everybody to join the WhatsApp group. If you don't have the link, that's also perfectly fine, because you will be notified over your email for every communication. 6 months internship is online. Sabudh give everything online. Whether you are giving test for the internship or you are giving interview for the internship, everything is online. But yes, we track each and every progress of every intern throughout these 6 months.
Ma'am, what will be the syllabus of assessment which you're going to take on 30th?
Again, like see, you have Rakshita ma'am with us. We have, okay, she mentioned in morning also. Please, I'll just share my screen to give you the website. Share the, just a minute.
Hello.
Suparna, are you there?
Yes, yes. Can you hear me?
Yes, Suparna, thank you. So you just see a Sabudh website. Suparna, allow me a minute, please. So when you
Sure.
go to Sabudh website, so you can click on any of the programs. Suppose I'm clicking on data science. So we have FAQ. So mostly your questions will be answered through FAQ only. Mostly, whether it is online, offline, what is the syllabus for aptitude, everything will be there. I would suggest everybody to just have a look on FAQ, then come tomorrow as a fresh and ask questions if some questions are unanswered. Okay? Thank you. Over to you, Suparna ma'am.
Okay, ma'am. Thank you.
Thank you. Thank you. Am I audible? Okay, fine.
Yes, ma'am, you're audible. Just give me a moment. Let me start the recording. And meanwhile, I'm starting this recording. So, just to inform you all, now our session will be a formal introduction to linear regression, which will be given to you by our data scientist, Miss Suparna Datta. Over to you, ma'am. I am starting the recording as well.
Sure. Thank you. Thank you, Rakshita.
Thank you so much, ma'am.
I'll just share my screen. Hope my screen is visible.
Yes, ma'am.
Okay. So now we are going to introduce you to linear regression, which is one of the simplest machine learning algorithms. And we will learn what it does and when we will use it, its application, and how it works, and so on. Okay. So let's move forward. So let us see at this data. Okay. Can you find, so you can see it's a very simple data. Okay. You can see the X column, you can see the Y column, and very well you can understand that Y is twice of X, right? And if you plot the points, you will get a plot, set of points like this. And if you want to know the Y value for an unknown X means an X value that does not appear in your data set. What you see on your left hand side, XY, that is your data set. Okay. So if it is there, well and good, it's one of the points. But suppose I want to know the value when X is equals to 5.5, which is not there in the data set. So I can use this graph that you can see with this red line. And if you, this we have done in school life also. So if we just plot a line from X and then go to Y, we are going to get the Y value. So here the relationship between X and Y is very simple. We can easily, interpret that how Y is influenced by X. So here X is the independent variable because X can take any value, and the Y is called the dependent variable whose value depends on X. Okay. So linear regression is basically to find out this relationship between an X and Y and kind of coefficients, a set of coefficients, which gives, a fair picture, approximate picture of the dependency of X and Y. So if we give a definition of what linear regression does is it finds the best fit line that defines the relationship between X and Y. And here it does, right? Now, let us see this. Here, it's very difficult to write an equation where the scores are dependent on R's. This is another data set where the scores is dependent on the R's that you see. And if you plot the graph, you will see that the scatter plot looks like this. And it is not possible for us to draw a equation where coefficients with coefficients, and you can draw that line that we did in the previous example. So here you see that red line, it will not pass through all the points. What happened in the previous cases, it was such a well-defined relationship between X and Y that the red line was passing through all the points. So the equation was very accurate without any noise. But in real life, data has a lot of noise. There are unknown factors which influence the value of the dependent variable, which we plot along the y-axis. So the job of the linear regression is basically to draw this red line, to find the best fit line, so that if you if you want to know the scores for an unknown value of ours, the answer that you get from this red line is the best value that you can get, okay, that you can predict from this data set. This data set, what actually this algorithm does is it uses this data set to find out the coefficients and the dependency between x and y. What are the factors, how do they influence each other, what that plus something minus something, this and that. So this is the optimum, okay, this is the best fit line. So these were very simple examples. I will give you a real life example where linear regression can be extensively used. See, the problem here is to predict the price of a real estate company, a buy real estate company, which is you can say this, a housing company, whatever. And we know how the price depends on, right? The size of the house, how many square feet it is, how many bedrooms it has, what is the location of the property, whether it's on main road or not, where it is in the interiors, that's the location, furnishing status, whether it is semi-furnished or fully furnished, so on. So this is a data set. This data set is freely available over the internet. You can get this. It's a housing price data set. And this data set, you see, has 13 columns in it. Okay. And all these 13 columns has a different kind of relationship between the price and the and itself. Like for size of the house, if there's, it's very obvious that if the size of the house is big, the price will also be big. But there can be other factors that will bring it down. Maybe it is poorly furnished, the condition of the property is not good, its location is not good. So, in spite of a larger area, its price will come down because of other features. So, if you plot the relationship of these four features I've plotted, see the area, how the area of the price is related to the area and price related, you can see in the right hand side top, the first graph. Then in the second one over here, you can see how the price is dependent on the bedrooms. If it is one bedroom, then the price is varying like this. But you see how, why it is varying, because there are other factors also which is influencing the price. Then you see whether it's main road or not. It's very much obvious that if it is on main road, then the price is high. If it is no, then also sometimes it is same as that of yes, main road, but there can be other factors which is increasing the price. So but you see, if you see the data set, but all these factors together is giving you one price, right? So all these are called the features. What we see, these price, area, bedrooms, bathrooms, guest room, these are called the features. These features together contribute to predict the final price of the housing. So now the task of the linear regression model will be to find out that final best fit line, or the final set of coefficients, which when put in that equation will give me a value which is very close to what it is in real life. It will not be accurate, it will never be 100% accurate, but it will be the best value, okay, that you can predict from given data set. The algorithm actually learns these coefficients from the data set you have given. So the more authenticate and more genuine your data set is with true values, the better the prediction is. If the data set is of poor quality, your prediction will also be of poor quality, because it is following the data set. It will use your data set to fix the coefficients and weights. We will come to that. So why we are taking linear regression? To identify which feature affects the price, and as we have already talked about the coefficients, and helps us also to forecast future price. Now, in the name itself, you can see there are two important words. One is linear and one is regression. One is linear, is that we are assuming that the relationship between the dependent and the independent variable is linear. Okay, so that means so in all the cases that I've shown you, see, they are linear over here, right? Scattered linear. It's not, parabolic or otherwise. Okay, you can draw a linear relationship between them. Okay, we'll come to the assumptions later on. And regression means to predict a value. Okay, it's not classification. It is not going to help you to categorize something, whether it is this type or that type, like we have class 1, class 2, yes or no, whatever, but it will give you a continuous value as an output. Like here we take, right, to price. The price can be any value. Okay, so it is a numerical value that you want to predict. So linear and regression. Um, So we have already talked a little bit about the objective of linear regression, that it approximates the relationship between x and y. Uh, it helps us to estimate how y changes with unit change in x. It creates a model, so which can predict the value. So after the learning process, we'll come to the learning process. After the learning process, what you get is a model, okay, who actually has the coefficients and the weights, which will help you to put in that equation and predict the value of the y from the given x, right? So in this housing case, if you give the like in this example, do I have it here? No, I don't have. So there are some discrete values in these, like bedrooms. Okay, you can see the discrete values over here. So in the bedrooms, you can see what are the values in the data set: 1, 2, 3, 4, 5, 6. So if you give these valid values, you can see the data type. So if you give, except for the price, the top one is my target variable and the others are my features. So if you give some values, the valid values for all of these features, it is going to use those features and it is going to give you a price. Okay, now let us come to the assumptions of linear regression. So assumption, as we already learned, that the relationship between the dependent variable and the independent variable is linear. Okay, we are assuming it. So basically it is our choice that what kind of a model are we going to use for a particular data set. And if we see, if we will always, whenever in real world we are given a problem statement, we always first study the data set, and then we try to see the nature of the data set, and then we decide that what kind of a model is suitable for it. So for that we have, EDA, that is data analysis, exploratory data analysis, where we look at the nature of the data, and when we see the target value, which is in the dependent variable or price over here, has a linear relationship between all the other features, then we say, okay, linear regression we should start with. Okay, we are not saying that our decision will be always correct, but suppose we see that yes, linear regression is the best match for this kind of a data set. Like for the R's example that I gave you, linear regression is the best over there. Then is independence of the errors. The error, that is, or also known as the residuals, are independent of each other. That, what do you mean by residuals and error? Now see this data set that you have given, while your machine is learning, we will predict, okay, we will use the same model to predict the values from step by step. And we are going to see how close the prediction is to the actual value. Okay. Uh, Suppose we have the data set, it has 5,000 rows or 5,000 data points we see. Now, out of these 5,000 data points, we have kept 3,000 data points for training the model, that is to, to to create, to generate or to learn the weights and coefficients, and other 2000 to see how close my prediction is. So it's like, taking an exam. Like we give you an exam, no? We give you the curriculum, known data set, and you learn from there. And then we give you some unknown questions. Yes. And then you are evaluated on that, and we see how close your answer is to the actual answer. So that is your error. So here also the algorithm which is learning, the model that is learning, we evaluate that model also. Okay. And I will give the x value to the model, and it is going to predict some y value, and I have the y value. The model was not provided with the actual y value, which is called the ground truth, and we see the difference between y and y dashed, which is the predicted value, and that is the error. Okay, now here it's saying that the error is independent of each other, so that one error is not dependent on the other. You might be thinking how it should be, but it happens in some cases. So here they are absolutely independent. There's no autocorrelation between the errors. Homoscedasticity is the constant variation of errors across all values of x. Okay, so this is also that for every value of x, the variation of error is also similar. Okay, normality of errors, residuals follow a normal distribution. Okay, I'll go back to point 3 again, where it is saying that the constant variance of errors across all values of x. That means for every value of x, it is a normal distribution, and every normal distribution has the same variance. Okay, and no multi-collinearity. That is the independent variables are not highly correlated with each other. This is important. Suppose now in this set of features, now if I come back to this, these features are the independent variables. Okay, they don't influence each other. That means a change in one value does not change the other feature, but all of them together influences the price, which is the target, which is the dependent variable. So here area is not dependent on bedrooms is not dependent on bathrooms. Okay, so none of them are dependent on each other, but there can be some data sets where there are redundant uh, features. Okay, and if change in one of the column changes the other column also, so in those cases we have other measures, like we drop those columns first. We find out the correlation between the features, and then we drop them, because what happens is then that feature starts to have a greater dominance in the prediction. Okay, so here we are saying all the features are they are not highly correlated with each other, and x and y are measured accurately. We say okay, x and this, and we assume that the data set is proper. And now we come to the mathematical part of linear regression. Any questions till this point? Now this was all non-mathematical portion, that why we do it and how we do it. Now we'll go to the formula and everything. Any questions till this point?
No, ma'am.
Okay, just give me a second. I did make some changes that is not up here.
Suparna, are you there?
Yes, I'm there.
Okay.
I'm there. So this is the functional form of the linear regression, where y equals to beta 0 plus beta 1x plus epsilon. Now, this equation is very similar to a straight line equation that we have done in a school life in coordinate geometry. Remember? We have y is equals to mx plus c. Yes. So, and this error, this epsilon is basically the noise. See it, what it is written? It is the unobserved factors. Otherwise, it will become a straight line. And, real life data is not straight line. Okay. There's always noise in it. Other factors, unknown factors which rule. Because basically some human factors also go in. So, mx, this is mx plus c. So, remember c was the intercept, right? And this one was m, which is the slope, and this is the x value. So here is the interpretation of the equation. So basically this model is going to learn beta 0 and beta 1, right? And it is going to come with some value, okay? And it is going to use it for an unknown value of x to predict the value of y, okay? Now, once your model has learned this, I will also discuss how the model learns these values. Suppose somehow whatever is the process of learning, beta 0, some approximate value beta 0 and beta 1 has been come down to, right? Now I'm going to give a known value of x from the data set, not known to the model. The model was not aware of this point, and I've given the value of x. And what it will predict is called the x cap. What you can see here is x cap, okay? And we say that the cost function where the coefficients are beta 0 and beta 1, this is the cost that you're calculating, average cost, where y1 is the actual value, which is the ground truth that you know, okay? And the model has predicted y1 cap, and you find out the difference between them, okay? And you square it and you divide by n. Now why do we square it? Because the predicted, this removes the negative values, and then why I will discuss it. It removes a negative value. Now for example, you say my model has not learned at all, okay? And the value should be 10 and it has predicted 20. So what is my error over here? If I don't square, 10 minus 20 minus 10, okay? And for another data point, the actual value was supposed to be 34 and it has predicted 24. So now the error is plus 10. Now if I find out the average, the error will be 0, because once it predicted 10 higher, 10 points higher, more 10 more, and once it predicted 10 less. So I'm not, now there will be thousands of points. I'm not going to see each and every point one by one. I'm going to use a mathematical formula to find the average and evaluate the model. So if I do that, then ultimately the model error will be 0. I'll say, oh, wow, my model is learned very nice coefficients, is giving me 0 error. So that means every time the value was correct. And now when I use it is going to give a horrible form, prediction. So what we have done is we have squared it so that we don't lose onto the error. In this way, we were losing the actual, error tracking, right? So here what we get is the mean squared error. This is the MSE. Okay. How it is done? We take the difference between the actual and the predicted and we square it to avoid, like I explained, the negative penalizing the large, positive mistakes, and then we average it. Okay. So this is the average error that you've got. Now, if you plot this, the cost function for a linear regression, you will get a bell curve like this. Okay.
Excuse
Any
me, ma'am.
questions? Yes.
Is it predicted minus actual or actual minus predicted?
It doesn't matter. You're ultimately squaring it. You will square ultimately, right? Whether
Yes.
it's negative or positive. Okay. So this process of learning the weights and knowing whether I have learned, come down to the correct coefficients of not or not, is called the gradient descent over here. Okay. And this is a step-by-step optimization algorithm. Okay. Now this is the bell curve of the cost function. This is the cost function of graph of the linear regression. And since it is the MSC, that is why you get a bell curve like this. And why it is very convenient to use a cost function like this, because we have a global minima over here. This point, I have it marked here. This red point that you see, this is a global minima. So that means at this point, the error is minimum. Okay, the error is minimum at this point, and this is my target point to reach by approximating the values of the coefficients. Now, how does this algorithm work? So first of all, we'll start with the random values of beta 0 and beta 1. These are the parameters, the random parameters that we have. We start with random. It's not possible to guess a close value or anything. We simply start with a random value. Okay, and we put that value in the equation. What is the equation that we have? Y is equals to beta 0 plus beta 1x. And then what we get is the Y prediction. We subtract it from the actual, we put it in this one, and then we find out the error. Now, if error is very high, then what will happen? Then we will move downhill. Okay, we are going to then change the weights, the values of the coefficients, and then again find out the predicted value and the error and so on. And we will go on changing the values of the coefficients in the direction as long as it is decreasing, the cost is decreasing. So you see, if I start at this point, okay, obviously the error is quite high over here. You can see it is going to move in this point slowly. Okay, these are called the epochs, that how many times am I going to repeat the process. Okay, so and every time it does, no, it does with the entire data set. Okay, and finds out the mm, it finds out the cost function where it is, and then it then updates the, now we'll give you the equation for updation also. It updates the values of beta 0 and beta 1, and then again repeats the same process until it reaches the global minima. Okay, it goes in this way, and then when it reaches this point, it says, okay, this is the minimum. Then I can stop updating my features, coefficients beta 0 and beta 1, and I can say that the model has learned. Now, how will the model know whether it is the global minima? What will happen is, once the ball starts rolling from this side, it is observing the cost value, right? This pink line is the cost value. Now, at this point, it's in decreasing, and it reaches this point. Now, it doesn't know actually whether it's going to go down or it's going to go up. So as soon as this ball starts rolling up, it realizes, okay, the previous one was the global minima, because after this point, the cost increases again. So then what it does is, we don't have to do explicitly anything. The equation is so, beautiful, that as soon as it increases the cost function, the cost increases, in the next step itself, it comes down. Okay. Now you will say again it will then move in the same direction. No, we have other hyperparameters also, which controls that. Okay, now how am I going to come down the hill or go up the hill and then reach the minimum point? Those who have had done physics laboratory, I don't know how many of are you acquainted with a galvanometer, or when you want a reading, or you want a configuration where that pointer is just in the middle. We start with random values, right? And we saw suddenly that the pointer just shoot it on the right hand side of the galvanometer, and then we chose another random value and it shoot it on the opposite direction. So now we got, okay, so that is somewhere in the middle. Okay, and then it comes to a point where it is going to the right hand side and left hand side, but very slowly. Then we make small changes, right, in the resistance that we choose, right? First we were changing by 10, and then we start changing by 5 and then 2, and slowly you see the pointer shifts slowly, in and around the center point, and then we come to a value of the resistance we get where the pointer is straight. So this is also in that way. So that is the learning rate. So the learning rate is how big steps it is going to take to reach the global minima over here. Okay, so when it comes over here and takes a big step over here, then we can decrease the learning rate, and then in small steps it can come down, so that it does not go around from this arm to this arm like a pendulum, that is once going on this side of the curve, once on that side of the curve. This happens when the learning rate is very high. So we always do, we tweak the hyperparameters like the learning rate, the epochs and all the, and then we make sure in what values it comes to the minimum. And for that set of hyperparameters of learning rate and epochs, we get the global minima, and we say, okay, this is the entire equation. Okay. Any questions on this learning process? It's quite simple, and it is simple mathematical process. Okay, a for loop runs, it evaluates, it finds out the value of y for every data point, it finds out the error, the average error, and sees whether it is increasing or decreasing, and then it moves on to the next iteration again until it doesn't change anymore.
So how do we specify the epoch size? Is there a...
So these are all permutation, like you have to go on to trials. Okay, you have to go on trying that. Okay, after these many epochs, it now I'll give an example. Suppose you first chose 500 epochs. Okay, 500 iterations. So it is, this loop is going to run for 500 epochs. You will always print the cost in every epoch or every 100 epochs. Okay, not possible for 500 epochs. So every 100 epochs you're printing the error afterwards. So you saw that the error is still decreasing. So you did not get a pattern that the error is stagnant. Okay. So when you reach the global minima, when your features on these things reach a global minima, you see the cost is neither decreasing too much nor increasing too much. It's like a change in the 5th decimal place or in the 6th decimal place. So that means your cost function is not now stable. Okay. So you saw you did not see any stability in the error. So now you increase the epochs. You make it 1000. Okay. And in 1000 you saw that after 750 epochs, your iteration stopped by itself, because our logic is also right like that. So we will see if in 2-3 iterations, if the change in the error is only in the 5th and 6th decimal place, we terminate the loop. Okay, so you see, okay, then that means 750 epochs is my actual one. So in this way we do all these kind of experiments. We need to see the error ourselves, that whether it is stabilizing or not. If in the last iteration also, if we saw that there was a decrease in error, that means it needs more epochs. Now if you see the epoch was decreasing, okay, and suddenly it increased, that means it is taking big steps. That means it moved from this arm to this arm. So now you have to decrease the learning rate. So this learning rate is actually jumps. Like you can see this, like you can imagine these arrows as the jumps. So from this point, if takes a jump, it will reach this point, and it will go up like this. It will go on increasing now. So you understood that. That means learning rate is too high. So what you will do, you will decrease the learning rate. So now it is going to take small steps. In this way, small steps. In this way, that it is going to reach the global minimum. That means you will see that your cost function is becoming stable. Okay.
And initial weight is parameterized by the user only.
No, it's random value. You can use any random function to generate.
Okay. and do we need to vary it or certain whether it should be too small? Means it
Nothing,
should be
nothing. Just use a random function
random.
to initialize. Okay. Now on this graph, I've shown you that this side of the graph is a positive gradient. Okay, if the ball is on this side, but you don't know from where the ball will start. It will start from, it can start from this arm also, it can start from this arm also. So in this case of the diagram, it started from the positive side. Okay. Now comes the gradient descent updates. Now our objective is to reach the minima. Okay. And we know from derivatives that if we find out the derivative of x dx dy, and if it is 0, then it gives us a maximum, right? But here we want to reach minimum. So that is why you have this negative sign over here. So this is j is the cost. This was because there are two coefficients in our equation. If you remember the equation, this one, we have two coefficients, beta 0 and beta 1, right? So in both these cases, we have to find the derivative with respect to both the coefficients, beta 0 and beta 1. Okay. And the negative sign, I told you that it is because we want to find the minima and not the maxima. Okay. And this negative sign is actually very crucial, because the derivatives, as I told you, naturally points towards the increasing uphill of the curve. But I want to go downhill towards the global minima. No matter on which arm I start on a random value, in both the situations, I have to go down. I don't want to go up. So that is why the negative sign is there. Okay. And then what happens is, this is the updation. That means in every iteration, this is the learning rate. And so after first iteration, so this is the change that has to be done in beta 0, and this is the change that will be done in beta 1, and that is updated, and this new value of beta 0 and beta 1 will be used in the next iteration again. And this way it goes on for as many epochs as you have given, right? There is no model that you're using. You can implement linear regression using numpy. Okay, just write down, implement these functions using numpy, and you can build a linear regression model. So here comes a bit to are the other two hypermap parameters that really have crucial role in the learning process, which is the linear learning rate and the epochs. Okay. Now, this learning rate, when it is too small, I've told you what, too big, I've told you what will happen. It is going to miss the global minima. It is going to just, shuttle from this arm to that arm and never meet the global minima. But when it is too low, then what is going to happen is the learning rate, the learning process will be very slow. Okay, you will need a lot of epochs, and that increases the computation cost. So we always have to try, give trials and come to an optimum value. It's up, like, whoever is building the model, that he has to do all these experiments, combinations of learning rate and epochs. Okay, and epochs is one full pass of the training data set, and more epochs means better learning up to a limit. As I told you, it should be optimum. Just give me a minute. Sorry. Give me a minute. Okay, any questions till this point? Okay, I think this is quite a, did I share my screen? Is my screen visible? No, no. Sorry.
No, Suparna. We
Okay,
can't
okay.
see.
No, no, it's okay. I'm done with my this thing. I think this covers all on a, for an introduction in linear regression. You can ask questions if you would like to. Am I sharing? Why is not sharing coming?
Yes.
Now you can say? Okay.
Yes. Yes, ma'am.
I don't know why it is not showing. Because I'm sharing, but still it is, giving me the sharing option.
Now it's visible. Yes, anyone having any sort of concerns or anything? You may open your mic and ask ma'am the questions or put it in the chat box.
No question, ma'am. Thank you.
Thank you.
Thank you, Suparna. Such a wonderful session.
Thank you.
Thank you so much.
Shakila.
And
Thank
gradient
you.
descent was too, this was the too simple way to discuss the gradient descent. Thank you so much.
Thank you.
Thank
Like I should not, scare them, no?
Yes, yes, yes.
They should not be scared. They
I
have
just
to.
like the way जो आपने left and right arm का भी बहुत बोला ना कि it can start from the positive side also. So I was not covering this thing in my sessions.
No, no. It's like as you speak. Okay.
Thank you.
Thank you
Thank you
very
so
much.
much. Thank you.
Bye.
Thank you. So I think Rakshita, we have another 15 minutes for the lunch break, is it?
Yes, ma'am.
So now what we can do is, because we have another 15 minutes, we can take queries, we can take your doubts regarding the internship, but only for 15 minutes. Then we have, doubt session scheduled for tomorrow. So you can ask questions in another 15 minutes related to internship. Anyone? कोई question नहीं है आपका? Can I apply for all? Yes, Sanjeev, you can apply for all the programs, but it will be difficult for you to complete all the programs. So you will be applying all the 3 programs, then we will evaluate your performance in the aptitude test. There are 2 criteria of selection in the internship. One is aptitude test, second is the interview. Aptitude test tentative date is 30th of November, or most probably it will be 30th of November only. We will not be extending the date. Then for the interviews, we will be giving you 4 days, 6th to 9th of December. This is again tentative. You can attempt your interview any time of the day for half an hour from 6th to 9th of December. If you clear both the criteria, then you will be able to make the spot in the internship. But it is difficult for you to manage 3 internship concurrent. It will be difficult for you because एक पूरा internship जो है, it demands at least 48 hours of commitments from your end. When I am saying 48 hours, it includes the teaching hours, it includes the learning hours, it includes the time that you are spending in completing the courseworks, assignments and project work. You can apply, you can try your luck कि आप किस में select होते हो, ठीक है? So we have a very limited seat for AIoT. Maximum we accommodate 30 people in AIoT, artificial intelligence for Internet of Things, 60 to 65 in data analytics, and 200 because we are running data science program for past 8-9 years. So we are accommodating 200 to 250 students in data science. So you are working professional. The timings of the we don't work on weekends. This is the only day जो workshop का है कि हम लोग weekend पे work करते हैं. We work on weekdays. Classes will be happening on weekdays only in the working hours from working hours normally are 9:30 to 6:30, but we start with the classes from 8 a.m. Those who are working professional, either they manage to attend the live classes. Also, we will be giving the recordings. But apart from the live classes, you have to commit time to complete the tasks also. So I would suggest you can apply for part-time internship in data science. Part-time is only available in data science. But if you are opting for part-time, we will not be providing you the project. And for the data science, the best thing of Sabudh Foundation is that we are giving you exposure of passion project, and project is similar to the live project. So if you have missed the previous 2-hour sessions, number one, we are also streaming this session on the YouTube. We can share the YouTube link with you. Also, we will be sharing the credentials of Adobe Lab, which is our learning platform. You can get access of the recordings. All the programs will be having same aptitude test and interview will be डिफरेंट एप्टीट्यूड टेस्ट एप्टीट्यूड है ना, उसमें डेटा साइंस या आईओटी या उसके रिलेटेड क्वेश्चंस नहीं होंगे. If there are questions, those will be very basic things, basic questions, but interview will be different for all the 3 programs. So we will be selecting the candidate among 3 courses. First is we are selecting on the basis of cutoff. Second is if you by chance get selected in all the 3 programs, then we will give you option to choose one out of those 3. I think I have answered your question, Mohammed. Divya, what kind of task? So during the internship, Divya, we will be giving you the courseworks, the high level courseworks we call them. So just today, we just shown you a small code predicting the salary. So this is one small course. So there are high level courseworks. So which takes time to complete. So task means those things. Also, when you are there in project, working in project, so your mentor, we will be assigning mentor for the projects. So if I just talk about data science, in data science, 4 to 5 people, they are working in a team for a project, like you work in real time, real industry. So your mentor, there will be 1 or 2 mentor to mentor you for the project to a team. So mentor will be there to mentor a team. So they will be giving you weekly tasks. Okay, now you can you please complete this thing. So this is how you will be running your project. So these are the tasks. Project, yes, in data analytics, we will be completing all the modules. Just download the curriculum from website. Once we complete all of the modules, in fact, in the middle of the internship only, I would not say middle of the internship, in last 2 months, we will be giving you a capstone project. For data analytics, there is a capstone project. So once you learn the modules, you will be able to make that capstone project. The pipeline will be given by Sabudh Foundation, and you have to fit your codes and tasks in that particular pipeline. Aptitude test syllabus is there in FAQ. If I have to tell you, that will include the general English, general mathematics, logical reasoning, critical reading. So these will be questions and very basic questions about the understanding of the technical field like data science, AIoT, and data analytics. So Dheeraj, I have already answered this question. Aptitude test will be same. It will be on the same. See, we will not, giving different slots for the aptitude test. There will be one slot. If it is happening on 30th of November, it will be happening in 1 hour slot. Everybody has to appear for the aptitude test. If you miss the aptitude test, you will not be called for the interview. And if you able to meet the cutoff of the aptitude test, you will be called for the interview. When I'm saying you will be called, it means you will be notified over your registered email. I'm just stressing upon this point, email, registered email. Okay, so please try to see your registered email regularly, check your emails regularly, and interviews will be different. And for the interview, we will be giving different, we will not be giving the slot. It will be happening, aptitude will be happening. We will conduct aptitude on EduClab only. It will be just like an online MCQ test. And for the interview, Tatras has its own AI platform. So their interview will be AI only, AI based only. You will be asked question for half an hour and you will be answering, recording your answers, and you will be submitting. But yes, it will be proctored based. Your every activity will be noticed. If you are trying to getting, you have to attempt the interview in the full screen. If you are trying to log out from the full screen, your interview will be cancelled. If you are trying to seek help from any other browser and any other device, it will give us a report cheating detected. So again, your interview will be cancelled. So it will be on AI platform, and for each program there will be different interview, and there will be 4 days with you: 6th December, 7th December, 8th December, 9th December. We will be sharing the link over email. You can access that link any time of the day of out of these 4 days. बस आपको वो submit करना है. Third year student can join the internship, Jairam, unless and until you are able to devote the time. Because we don't want you have regular commitments in the college and you are struggling between the internship and your educational, commitments. There is a lot of dates in finalizing the selection. What if I miss a particular process? We are working, we usually forget dates. I didn't get your point, Abhijit. Finalizing the selection, lot of dates. So basically, once you registered for the internship, when you have registered for the internship, we have sent you an automated email, जिसमें already tentative dates लिखी हुई थी. Then yesterday only, in fact, before yesterday, few days ago, we put a message in the group also कि tentatively आपका वही रहेगा जो workshops है 15 and 16. So आपको we just sent the emails also. So अगर if there is any change in the dates or timings, you will receive prior information over your email. Don't worry about if you forget the dates and timings. You don't have to visit any institute, Dheeraj. This will be all online, whether it is the registration or aptitude or an interview or the live classes. Cutoff we will decide, Mohammed, on the basis of number of the applicants who are appearing for the aptitude test and who are appearing for the interview. That we can, but if I tell you about our past experience, the aptitude test will be of 50 marks, and those who are scoring 40, we are calling them. Below 40, we are not calling them for the second round. That is interview. These all courses are suitable with the college program. This certificate is valid. Data science, data analytics, these are the cutting edge topics these days. So answering to your question, Muhammad Khalid, means handling, you can see if your stream in the engineering or any the field that you are studying in your college is related to computer science, mathematics, statistics, IT, then you are at the right place. Interview questions, Divya Gupta, mostly will be general questions, because we will not be asking core technical questions, because we are here to teach you. We will be assessing your एक तो aptitude test में जो questions हैं, we could ask the questions from the aptitude test also, just to assess कि आपने copy paste करा है या you have understanding of the things, because वहाँ पे camera is on, you are recording yourself and we are seeing those recordings. ठीक है, हमारे platform पे we are getting those recordings. So aptitude test में से questions होंगे, plus some general questions about yourself, whether you will be able to give time or not. So some very general interview will be there. It will not be like technical interview, because you are just you want to get enroll in the internship, not you applying for any job. Data science may maximum we can take 250, but yes, 200 to 250. Sanjeev Kumar, anybody can join, whether you are a PhD student or you are a working professional or you are assistant professor, anybody can join. LMS course module will be available. See, right now we are recording the sessions. These will take time to get processed. maybe today's sessions you will be able to see tomorrow, and tomorrow's session you will be able to see day after tomorrow. And once we have created your login credential for EduClap, you can access those for the lifetime. We have never revoked the EduClap access for anybody. So, Mohammed, we have not registered with VTU, but yes, in current batch also, in the previous batch also, we have students from your organization. You please check with your training and placement coordinator in the college. Just ask them, because for last many years, I would say, people are coming here, they are getting the certificate, they are completing the training, and that training is valid in their college.
Ma'am, how many slots are there in for data analytics?
Maximum of 60 to 65, in the range of 60 to 65.
Okay, thank you, ma'am.
Thank you. And honestly speaking, because we are NGO, we don't charge any fee. We don't have to see कि हम लोग loss में है कि profit में है. So if you see our forms also, we have written, our fee is just commitments from the students. So if you are committed enough, we will get you in. But yes, अगर आपका aptitude में out of 50 में 10 score है, interview में you are speaking nothing, then we don't want that people in the batch. कंप्लीट भी तो करना है ना. सो इफ यू आर मोटिवेटेड इनफ, you are always welcome. I have registered for the Dheeraj. You can change to the full time. You please send an email, Rakshita, if we can share the email ID. So I will be taking questions for another 1 minute only, because then we will be having lunch break. So Rakshita, please share the email ID admin ka, so that Dheeraj can send an email. Okay, so he can switch. He want to switch from part time to full time. And also Dheeraj, if you can refill the form, okay, using another email ID, because you can't use the same email ID to fill the same form. No, you don't have to visit anywhere. So honestly speaking, this course is designed for the working professional, for the students, whether they are in India or abroad. Because online में क्या है, तुम कहीं से भी बैठ के पढ़ सकते हो. And in हमारे जो mentors हैं, they are also not everybody from the same place. So Suparna ma'am, she is sitting in West Bengal right now. I am sitting in Chandigarh. So you will be having professor who is taking the session from Delhi, and professor who is taking session from Canada also. So that is why we just design this program online only. Duration of aptitude test, Divya Gupta, is for 1 hour. Yes, the information abhik. Every information we will be sharing. The main mode of communication is the email. But yes, apart from the email, we will be sharing the information over WhatsApp also. I am pass out, unplaced. Biki, so you are at the right place. If you are pass out and you have not joined any job, you please go through this internship if you are interested in these fields. Honestly, Harjot, we don't recommend everybody or the full timer to just watch the recordings. Don't attend the live sessions, because you will definitely lose the pace. Recording से आप internship कर ही नहीं पाओगे. This I am just saying with my own experience. I have also completed this internship back in, this is batch 16 you are applying for. I completed this in batch 9. So you have to be very, very consistent in order to complete this internship. No negative marking in my aptitude test. Thank you. So I have taken all the questions. I think आपको एक idea तो मिल गया होगा. मोहम्मद खालिद, सबूद आपको जॉब लेने में हेल्प नहीं करता, बट यस वी विल प्रिपेयर यू फॉर द जॉब. व्हेन आई एम सेइंग द प्रोजेक्ट इंटरव्यूज, एआई इंटरव्यूज एंड ऑल, जो भी आपका इंटरव्यू है, सी इंटरव्यू में क्या करते हो आप लोग? यू आंसर द क्वेश्चन. कॉन्फिडेंस आप में है नहीं है, इंग्लिश इज द मेन मोड ऑफ कम्युनिकेशन, ठीक है. सो इन एवरी आपका जो अगर मैं इंटर्नशिप का पैटर्न बताऊं, इट्स फॉर 6 months, एंड इन 6 months वी टेक योर मल्टीपल वाइवास. every month you will be appearing for the viva, and every month ke bina bhi for different modules also we will be taking your viva. So actually it is preparing for the final interview also through the vivas. When you are working with the project, again we are making you ready for the industry, because industry mein kisi bhi project pe individuals are not working, they are working in a team only. So that is how we are preparing you for the we are trying to make you job ready. We will be giving you expert sessions, how you can curate your resume, how you shall be active, and how you shall curate your LinkedIn profile. So these kind of sessions we will be providing. And yes, if we get any, we will be taking your mock interviews also. We will be choosing some resumes. Whenever we get any requirement from some industry, we will be sharing those resumes if you are interested, but we don't guarantee that we will be giving you the placements. So thank you, Rakshita. Tatra's data, see, Tatra's data will not hire directly. Okay, so we have in current batch 400 students are there. We enrolled 400 students in current batch. तत्रस डेटा के पास 400 या 100 लोगों को हायर करने का कैपेसिटी नहीं है, बट यस, आप कहीं भी चले जाओ, अगर आप अपने कॉलेज में भी हो, ठीक है, कॉलेज में भी इफ दे हैव पोजीशन फॉर द असिस्टेंट प्रोफेसर एंड दे हैव सीन दैट दिस स्टूडेंट इज वर्किंग गुड, या इसके पास बहुत अच्छी नॉलेज है सिंस ग्रेजुएशन, एंड दिस स्टूडेंट हैज कंप्लीटेड पीएचडी फ्रॉम द सेम कॉलेज, तो कॉलेज के पास पोजीशन है, देन दे विल डेफिनेटली हायर यू, क्योंकि उनको लगता है कि ये तो कंसिस्टेंट रहा है. सो डायरेक्टली तत्रस ऐसे कोई हायर नहीं करता अनलेस एंड अनटिल वी डू हैव रिक्वायरमेंट्स. ठीक है रक्षिता, आई थिंक व्हेन आवर डेटा साइंस विल बी each internship, data analytics में there is only full time opportunity, no part time, and internship will be started from the first week of January. First week, when I'm saying, doesn't mean 1st of January, first week. You may expect orientation on 6th or 7th of January, then the classes in the next week. ठीक है. So thank you everyone. We are just, this session is on only. So we will be starting with the next session at 2 p.m. Thank you everyone.
Thank you so much, everyone. For the next session, you may join at 2 p.m. on the same link, and we will give a reminder before 2 p.m. as well, so that you can join back to the class. Thank you.
Hello everyone. I hope I'm audible to you all. Okay, thank you so much for confirming Jairam and Chaitanya. So let's just wait for a minute till rest of the people join and then we will be starting the session. Okay? Okay. So let me just have a quick confirmation. Gurjot sir, are you here?
Yeah.
Okay, great. Thank you so much for confirming. So let's just begin with our next session. Before that, let me just start with the recording. Just a sec. Okay. So hello everyone, welcome back. Now we will be starting with our next session, that is Inside the Neural Mind, Introduction to Deep Learning. And it will be conducted by Mr. Gurjot Singh, who is a data scientist at Tatras Data. Over to you, sir.
All right. Thank you for that quick intro. So I'll quickly share my screen. Let me know if it is visible to everyone.
Yes, sir, it's visible.
All right. Cool. So hi everyone. A very good afternoon. And today we will be discussing deep learning. And in particular, we will be discussing the introduction and we'll cover some basic concepts, which are relevant and important within the deep learning domain. And I believe some of you might already know these topics, but we will go with the assumption that this is that you guys are not familiar, and this will be a beginner-friendly session. Okay, so in case you guys have any questions, I would always encourage to unmute your mics and ask it right then and there. I prefer that as compared to answering questions within the chat interface. So with that being said, I'll start. I'll start with the uh, definition. So what essentially is deep learning? So it's sort of a subset of AI that allows us to make predictions given we have learned some patterns from our training data set, right? So that's what I've written. Again, I don't expect you guys to understand what is ANNs as of now, but as we discuss some of the things, we'll try to simplify these things and help you in understanding. So I'll sort of give a brief again. So it's a type of a method, ANN based method that allows us to create a model given some training data set, right? That's it, where it learns the patterns from. And then once we have trained our model, we can make predictions on a sort of a similar data. And the model architecture, the deep learning, the term deep actually comes from a number of layers that are present within the architecture, right? So again, I'll highlight all the points when we are discussing it, but that's what makes it different from the the traditional machine learning. So I'll stop right here. Let me know if there are any queries. I know this might be a bit difficult. I'll in fact even elaborate what do we mean by a model in data science and ML. But I hope all of you have a very basic idea.
Sir, does deep learning come under unsupervised learning?
No, not at all. So unsupervised learning is actually a sort of set of solutions wherein we don't have any annotated data, right? So an example of unsupervised learning is clustering. We have some sort of data points that are not mapped against any label per se, right? But in deep learning, we always have some labels present against some input. So it is a supervised rather than an unsupervised approach.
Okay, sir.
Any other questions that are there? This, by the way, is actually a good question as well, because you'll see while we cover the training aspect of a deep learning based model, there are forward passes and backward passes, and that would be only feasible if, let's say, we have labels. But there are some scenarios there wherein can we please mute the mic? Yeah, thank you. But there are definitely some deep learning based approaches that can be unsupervised as well. But their purpose is a bit different, I'll say. For the sake of simplicity, yes, there can be some unsupervised approaches within deep learning, like autoencoders. But usually you'll see in standard deep learning, there is always a label and using that, we are training our models. All right, and hopefully that answers your question. I'm not sure who was the one who had asked, but
Robert.
all right, cool. So now, in order to understand what do we need to create and train a deep learning based model, there are essentially four main ingredients that we need in order to set up a deep learning based pipeline. So like I said, a label data, right? That is definitely needed because that is how it's going to learn its weights. There are some parameters and hyperparameters I'll again discuss in detail when we touch base regarding what parameters are there in a typical deep learning based model. Then there is a transformation or a forward pass that takes place along with a optimization and a backward pass. So these are actually the core concepts within the deep learning modeling. How we are picking up any particular transformation and how we are optimizing those said transformation. This is where essentially the magic lies within deep learning. And there are different types of models within deep learning as well. We will be discussing a few of them, but my problem statement would remain sort of similar throughout the session. We will be focusing on classification task only, using different kinds of deep learning based models. So with that being said, so this is what I was talking about. We will be discussing mostly classification based problem. There are other types of problems that can be definitely solved or modeled using a deep learning based model. But we will, again, for the sake of simplicity, reduce the scope in which we will be discussing. So a classification problem, I believe all of you must have some very basic idea. We have some input data that we want to categorize. And again, depending upon how many categories we want it to be classified against, its name changes, right? So let's say if you want to predict two categories only, so that falls under binary classification. Can anybody give me a simple example? A simple example for like binary classification?
Sir,
Anyone?
email, spam, not spam classification.
Right. Pretty straightforward, right? So there are just two classes, yeah, spam and not spam, right? So that is a perfect example. Another example that I'll like to mention is, let's say, whether it's about, let's say, weather prediction, right? So whether the tomorrow, whether we'll have any rain or will it be sunny day, right? Just two of those classes. So that is again an example of binary classification. Now, if we talk about multi-class, so it's always greater than two classes that we are trying to predict. So, and again, my example, you can add in what sort of weather will be tomorrow, right? It could be raining, it could be snowing, it could be a bright sunny day, right? Or it could be windy. So you get the idea. We have more than two classes. So yeah, it is basically classification problem wherein we are trying to predict the classes. And just to give another example, what could be a non-classification problem that could still be modeled by a deep learning based model? That could be like, what is the temperature for tomorrow, right? That would be another prediction, but that is not a classification based problem. So I hope this is clear with everyone. Let me know if there are any queries. All right, I'll take that as a no. So in order to train a deep learning based model, I talked about we need these four things. So labeled data was the first one, right? So what we need in terms of labeled data, it is essentially some features or attributes that inhibit the properties of the problem that we are trying to solve, right? So in simple terms, like if again I talk about the weather-based prediction that I was discussing, so today's temperature and today's humidity probably could be a factor that determines, the coming days weather, right? So that could be probably an input to the model. And the output from the model is usually the probability vector for the classes. So again, if let's say it's a binary classification, so we will have two elements within the vector, one for each class. Or not two vector, two elements within the vector. So yeah. Okay, so in here, again, I have showcased a example of fruit classification. So we just want to categorize the given fruits. So there are three types of fruits showcased in here, mango, an orange, and an apple. So it's a multi-class classification, right? And now this is an interesting piece of feature engineering, I'll say. So in this data set right now, we have shape, color, seeds, and the skin type as the attributes of our or as the features of our data. So for instance, with an apple, like we can see, it is round, it has a color red, it has many seeds, and its skin is thin. This is just one way of, feature extracting and feature engineering. Depending upon the problem, you might have some other attributes or features for your, model that you want to train. So any questions still here?
No, sir.
All right. Similarly, for the probability vector, so this is simply a one-hot encoding that I've displayed. There are three classes, and for the positive class, we have kept the probability 1 in our training data, and for the classes that are irrelevant for a given data point, the probability is 0. Right. So this is also fed. This is, by the way, currently an output, but within the training data as well, this is fed along with the features of the data that I had shown in here. Additionally, these not all the features that we have extracted can be consumed by the model as is, right? So a lot of the times you might have to transform it. You might have to categorize the data against, since this is again a string, right? So you can one hot encode it similarly, or you can, for instance, add in some numerical values like what is the thickness of the skin in numbers, what is the weight of the fruit in kgs, right? So again, that is all different, aspects of the feature engineering. Okay, so with this, we have curated our label data. So, which is again a very important aspect. But once we get that ready, now we will actually proceed with understanding what a deep learning based approach does. And before I discuss that, I would sort of give a very brief insight onto what a model is. And in simple terms, models usually are a set of system that will ingest this input data and then make predictions that are accurate, right? In very simple terms. But what happens inside a model is that there are a set of equations, mathematical equations that convert your input data, or I should say, transform your input data into the probability vectors of your outputs. So that is what I have highlighted in here. So we have some input features. We do some process. Is there any question? All right. So given some input features, we do some process. Again, we'll discuss all the transformations that take place, but this deep learning based model helps us to convert those features into the output probabilities. So what happens under this sort of a black box? Let's see. So initially, if you recall, in here I had highlighted three things, right? So we already have the label data, but now all the other remaining ingredients of our deep learning based model, the parameters, the transformation, and the optimization, these are actually the core concepts which we'll discuss one by one. So what essentially a forward pass is. So we assume some parameters, W and B, that transforms our input feature X and converts it into our output probability vectors. So these, by the way, are initialized at random. So you might ask how such a random attribute or a random variable you know can take in our input features and then make a good enough prediction for our output. The answer is no. Right now it has not learnt any weights within its model. But that is how the process is. We start with some random weights, and the equation that is very commonly used among different deep learning based models are a linear based equation followed by a non-linear activation function. Right. So in here, what I have represented is y in the form of our input features along with some extra weights, and B stands for bias. But again, this is just to add in some minor randomness within our model. And to top it off, we have added a sigmoid activation function. So any questions till now? I see there's a lot of text messages. right, weights and bias, and yeah, sigmoid adds. And so a quick question for everybody. So again, let's not take an example of fruit classification. Let's take any random example that you guys have in your mind. So what could be the possible range of W dot product X plus B? Since this is a linear equation, what would be its range?
Zero to one.
No, I'm just talking about the linear equation inside the sigmoid function, not the whole equation. Any guesses? Yeah, infinite. Infinite or within the domain of X feature vector, right? But infinite again is a right answer as well, because we don't know what could be the range of X. But what this sigmoid function does is it takes in that infinite range of this linear equation and squeezes it between 0 and 1, right? And that's where we get the probabilities of our output classes or categories. So hopefully that is clear. Yeah. So some of you did understand and have given the right answer. So this is where all of the magic happens, right? So we transform our input features using some parameters and convert it into our probabilities of the various classes that we have within our data set. So this is a forward pass only. I mentioned that the weights and the values for W and B, these are initialized as random. In order to achieve an optimal model, we need to sort of optimize these values so that, for all of the similar, features that we get as an input, we can make the right predictions. So in order to do that, we'll look into our next step, which is the backward pass, or it can also be mentioned as, back propagation or optimization within a deep learning based model, right? So, so again, this is just a quick example, because in here, what we are seeing is that input X is actually a vector of multiple attributes, right? So X1, X2, X3. So similarly, we will be having a dot product of W1, W2, and W3. This is just to showcase that both W and X are actually matrices or vectors rather than just a single value, right?
Excuse me, sir.
Yeah.
So what is the purpose of using sigmoid function specifically here?
So like I said, we are discussing classification problem right here. And in order to get our predictions within the probability ranges, that is 0 to 1, sigmoid helps us to squeeze any given value between 0 and 1. Right. So it is a sort of it's an activation function, but I'll again try not to use those technical terms. It basically maps a given range of values and squeezes it to 0 and 1. So that gives us the range of possible classes, right? Because that is the probability of that could be a probability of a particular class. And when trained, and after a number of iterations, we will get the correct probabilities, right? In the initial stages, it could be possible that we get completely incorrect probabilities because the weights are random. But after some time, given it has seen enough data, it will start making the right predictions. But again, the purpose for this is to squeeze the values and essentially transform the values within our deep learning based model into probabilities. Is that clear, Dheeraj?
Yes, yes, sir.
All right. Any other questions? All right. So, and one more important thing regarding sigmoid is that it is actually differential function as well. So usually within deep learning or within machine learning, we use differential functions only, meaning that they have their derivatives are possible. That is simply due to the fact that we can then back propagate our losses. So that another sort of benefit, I'll say, for sigmoid, but just for discussing classification, it's just to get the probabilities. So yeah, we were discussing this. So this is just a example, just to showcase everybody that both W and X are actually vectors, and they have different, elements within it. So X1, X2, X3, these could be the features of our data set that we had talked about earlier. And similarly, for each feature, there is some value of weight that is usually present in a layer, deep learning layer. All right, so we have discussed most of these things. So again, the idea is to fine tune the weights in such a way that any new data point that comes up, which is mostly similar based upon our training, we can make a accurate prediction for that. So yeah, before I discuss backward pass. So are there any questions from anyone? So this was just a quick recap. We have discussed the equation, the sigmoid, forward pass, as well as the data set element of it. So, all right, I'll start with let me see the chat as well. So there are different activation functions that are there. Again, let's say if we are discussing classification only, but multi-class. So in that scenario, sigmoid would not be a suitable sort of candidate for activation function, right? So in that scenario, you can use softmax. So it's another kind of a function that does the same thing, but rather than just for the two classes, let's say if we have 10 classes within our data set, so the sum of the probabilities of all those 10 classes would be 1, just like we had in sigmoid for two classes. right? So that is another sort of a scenario. There are again many different activation functions that are there. Yeah, TANH, ReLU, all of these are activation functions. They are all used for, different purposes. All right, any other questions? I'll quickly check the chat as well if I've missed anything. All right. Well, yes, Jairam. So deep learning in itself is actually a huge and vast topic. Uh, it takes months to study. So since we only have 1 hour, I have to, get you guys a very basic idea of how everything works. But everything is discussed in detail during the internship. All right, so let's start with the backward pass. So this is where we sort of make changes to our parameters W and B in such a way that, rather than making any random predictions, it sort of starts learning from the training data that we have provided. All right, so again, I'll reiterate. So initially we start with random values. We run a forward pass, which is simply just transforming our input features using this equation and then applying sigmoid. We get a y predicted value, and we use this value and compare some loss. Okay, so that loss value allows us to update our W parameter in such a way that the new W that is generated, it yields a slightly better prediction as compared to the first iteration that we had executed while training the model. Okay, so all we are looking at is what should have been the actual prediction and what we have predicted. Compute some sort of a loss. It could be a root mean square loss, or it could be any other kind of a loss depending upon both the problem type and the architecture that we have. We then make some changes. Back propagation just means we make some changes within our values of W, which is the weights of our deep learning based model, in such a way that we sort of minimize the difference between the actual Y labels and the predicted, or, the predicted labels that are generated using the model. So any questions till now? All right. So once this whole process of both forward pass as well as the backward pass that does the back propagation, if this is repeated n number of times, which is usually referred to as the training time of a model or the training period of a model, we will eventually get to a stage that this difference would be very minimal. And at that stage, we'll say, okay, we have got a model that does decently well, with the given given similar input features. So we say, okay, we have a model that we have trained on our data set, and then we can proceed with the usage, whether we want to deploy it somewhere or however we want to use that model. So, all right, I'll keep this slide open for a minute. So we have discussed everything that is highlighted in here. So what is a label data? What are the parameters that are usually present within a deep learning based model? How do we transform our input features to the output labels, which is forward pass? And how do we change the random values of our parameters and convert them into something useful, so that they help in making the correct predictions. So that is the optimization. Hopefully this simple concept is clear with everyone. Let me know if there are any questions. All right. I don't see anything in the chat box, so I'll proceed with the multi-layer perceptron. All right. So again, considering a similar sort of a scenario wherein we have some features, I've kept the same thing that we have discussed earlier. And we also have some probabilities for the training data. So how does a MLP, which is the shorthand notation for multi-layer perceptron, learns? So the inside mechanism that I have discussed, it's only the forward pass and the backward pass that I have discussed. But we can discuss in practical actually. So usually there are actually a series of layers that are stacked on top of each other. So we have the same set given features as our input. There is layer 1, which has its own parameters W1 and B1. Then it produces some output. We send the outputs to layer 2. It has its own parameters and so on. It goes till the output layer, okay, which has its parameters W5 and B5. This is then passed to our, in this scenario, the number of classes is 3. So this can be passed to a softmax activation layer to get the probability vectors for this scenario, right? But this is where deep learning gets its name. There are actually a number of layers that are stacked, that takes the input features, does a series of transformations. So for each layer, there will be some transformations that are taking place. And then the output is, or the classes is the output, which is the nothing but just the probability of different classes. And these different layers, these are also sort of referred as hidden layers within any deep learning based model. So yeah, and like I said, since this has a number of layers involved, that is where we get the name deep. So there are shallow networks as well that are there, which are single layered neural networks. But this is an example of a deep learning based model wherein there are multiple layers involved. All right, so with this, let me know if there are any questions, else we can, start discussing another sort of family of deep learning based models, which are convolutional neural networks. I'll give you guys a couple of seconds if you have any queries. Each layer is just taking the input from the previous layer and doing the similar transformation that we had discussed. Right, so these are different layers serve actually different purpose, but together when they are stacked, they help in converting your input feature X into your probabilities. And also, if the more the layers we add in within our model, usually we say, okay, the model that we have created is now complex. And generally, complex models can predict on complex data sets as well. But again, that is not a rule of thumb that I would say, but yeah. So do the layers are defined separately by the user? Yes. So there is complete control of the layers that you can define in the deep learning based model. Another example could be, let's say, if you are fine tuning an already trained deep learning based model. So in that, let's say, rather than this example that I have of fruit classification, let's say you now have a vegetable classification problem, right? So in those scenarios, there is a term which is called as transfer learning. So you might be able to freeze the weights, which means you will not train the weights for the initial layers and maybe just train the output layer. And depending upon the classes, then you can change your output layer. But in any sort of a deep learning based approach, you usually can, select, add in any another layer, or essentially the user has the control over each and every layer. Does a layer contains different variation of same parameters? So these are separate layers. So the weights are not interlinked. So layer one does that transformation independently, provides the output to the layer two that again in turns does its transformation independently, and so on. And then at the end, we convert our values that the previous layer has provided into the probabilities of our classes using our activation function. So I wouldn't say that there are different variations of the same parameters. These are in fact different parameters altogether. Any other questions from anyone? All right, so we'll then start with CNN. So this is again another type of a deep learning based neural network, which takes in input as an image. And again, the task is same. Like I said, we'll be covering classification only. So given an image, we want to classify it, whether it's a mango or whether it's an apple or orange, right? So in here, since we have an image, there are a number of ways in which we can, feed the network its inputs. One very simple scenario could be just to provide the horizontal pixel values of the image to the neural network. But as we know that the image is usually has a lot of pixels, that is probably not a good input that we could provide to our model. Because there is another thing that I actually forgot to discuss in here. Since we only had 3 different features, x1, x2, and x3 within our data set, the number of parameters are actually just dependent upon how many features we have, right? Assuming we just have one layer. So W1, W2, and W3. It is correlated to the number of features we have. If we provide an image as an input and the raw pixels as it is, so the model in turn needs actually a lot of parameters, and it would become almost so big of a model that it needs a very huge, training corpus to actually learn those correct weights. So raw pixels are usually not a sort of a good input that you can provide. And this is where we use convolution layers within a CNN model. So what convolution layer neural network does is it has a new concept of filters or kernels, you can say, which are again nothing but just a random, no, not exactly random as well, but these are matrices, like you see, that detect patterns through our image. So these kernels extract your features. How it does that? We start with a kernel at our initial point, and we do a horizontal and a vertical movement. So let's say we cover our horizontal edge first. So for each kernel, it performs a dot product between the filter values. So those are the weights, W1 and V1, and the actual patch of the image that we have, right? So the resultant of that,
लंच उनका सिर्फ आधे घंटे का था
the resultant of that dot product of the kernel and the image is actually referred to as a feature map. Okay, so it helps in identifying whether there are any edges, whether there are any, corners, whether there is a color change. All of those things can be easily identified by applying a dot product with a filter or a kernel, you can say. Right. And since you can assume, or maybe I'll mention it. So in order to identify or generate multiple feature maps, we would actually need multiple kernels, right? So each kernel has a separate sort of task within an image, you can say. One kernel could be just simply identifying whether there is a color gradient at a very small patch of an image. Another filter could be identifying any vertical edges. Another one could be identifying any texture changes and all that, right? So different kernels generate different feature maps that can be, then further used as an input to a deep learning based model. So I'll quickly sort of explain this as well. We are sort of running short on time, but I'll try to explain this. So given an image that we have, we had a kernel that is going horizontally from top to bottom approach, right? So this is just one scenario. So within this kernel, once we run the dot product, and max pooling is essentially within that kernel's dot product that we have taken, it picks up the maximum value, right? So let's say if we had a kernel size of 2 by 2, okay, for the simplicity purposes, once we do the dot product of this kernel size with this patch of the image, and then pick the maximum value out of the 4 values that the 2 by 2 matrix has, we get with an output of a smaller kernel size, right? Because from 2 by 2, which is 4 values, we now have only picked one value. So with this way, we are actually downscaling our image while maintaining the right features within our image. Okay. This, when repeated again multiple times through multiple convolution and multiple pooling layers, it sort of generates a very small matrix, which is just the representation of our image only. You can consider this, right? It's a small representation, which we in turn flatten it out. So now, since we have made it smaller from, let's say, million of pixels in our original image to something just couple of thousand pixels in our final sort of reduced form of our image, we can now convert it into a one lengthy vector, because the number of pixels are very limited. We don't have million values within our image, and just execute it across the MLP, the fully connected layer that we had discussed previously. And again, applying the right activation function to get the class labels. So this is how using convolution layers and the pooling layers. Also, there are different other types of pooling methods. Max pooling simply picks the maximum value, but there are average pooling, minimum pooling. There are different other approaches out there depending upon the color gradient. So if, let's say, your image is mostly white, and it has, like, an example could be MNIST dataset. Most of the image is white, wherein just the numbers are in black. Max pooling might not be the right approach in that. Probably minimum pooling would be the one out there, because one or the highest value is represented as 255 within an image, right? And that is usually for the white color. So again, depending upon your problem type, you can customize also the pooling layers. So any questions till now? Just check the chat. Okay, so there is one question. What does this fully connected layer means? So it is nothing but just our previous neural network that we had discussed, the MLP. So a lot of the times within, in fact, in most of the CNN architectures, you will come across this fully connected layer. This, by the way, is sort of also referred as a dense layer, because this is where we are actually taking in our reduced form of the input and then converting our data into output values. So is that clear? Also, just since I know I have some limited time and might be I'm missing out on certain key things, I'll also add in here each of these are referred to as neurons. So each neuron actually is doing the same transformation that we have discussed earlier, right? So this, when applied across another layer, this when connected with another layer of, uh, uh, of a similar size, computes actually across all of the neurons that are available. That is where it gets its name of fully connected layer. But this is exactly the same thing that we had discussed in the MLP piece. This is also a fully connected network. There is one layer, then layer 2, then layer 3. That's all is being highlighted in here with just 2 layers as an example. So where we use CNN medical heartbeat monitoring. So see, CNN is usually used in a image problem, right? So I'm not sure how that can be applied to the heartbeat problem, but if let's say we have some examples of maybe a chest X-ray of the heart, a healthy heart and a non-healthy heart, we can use that data to train our model. But the main thing to note in here is that the inputs for our CNN should be an image, so that we can apply this convolution plus pooling layers, and then essentially convert our image into our 1D representation, which is a reduced form of the image. Yeah, MRI, exactly. All right. So those are the sort of the right examples that Jayam has provided. Any other questions that are there? Yeah, so these previous layers, Dheeraj, these are the convolution plus pooling layers. These are different to the fully connected layers in the CNN architecture. So yeah, these are different. That is a different thing, Kamal. Sign language. Yes, within sign language, yes, CNNs can be used. Because of course there is a video, but you can convert the videos into set of frames, and then that is doable. All right. So I actually had planned of discussing RNNs as well, but given we have crossed our time limit, I'll stop right here, and let me know if at least till both the MLP and CNN, if there are any questions. Well, it can be used, but CNN is usually used for images only. So again, like I said, we have full control over our architecture, right? This exact architecture is known as a CNN model. If we, let's say, don't want to interact with the image as an input, we can remove certain layers, but then the remaining model is not exactly a CNN model, right? So there are other sort of models. So CNN I have already provided. It is used to make predictions within a image data, and RNN is usually the next sort of approach wherein we want to predict what comes next given some inputs. So this will be I would suggest let's keep it for some other time, otherwise this will cause confusion among you guys. Hopefully till now I'll quickly just go through previous slides as well. If there are any questions, you can let me know. So we have discussed the different ingredients within a deep learning based approach, how we can select certain features within a data set. Yeah, I already mentioned. So for videos, you can, convert them into frames. So depending upon how many frames per second you are recording, you'll get let's say if 60 FPS, you'll get 60 images within a 1 second of a video. Right, exactly. Then this is next sort of family, which is VITs, vision transformers. So since I haven't discussed that, so I was sort of preferring towards the first approach. But there are many things out there, guys. So this session is only purpose is to give you an introduction to deep learning. But the core concepts are vast. So with that being said, I'll stop presenting right here. Let me know if there are any final questions. All right, then. Thanks, everyone. Over to you.
Thank you so much, Gurjot sir. Thank you for the nice explanation of introduction. Nice introduction to deep learning. Thank you so much. So we have our next speaker with us, Mr. Akshay Kumar. He is also data scientist at Tatras Data. So he will be giving you a walkthrough he will be giving you a session on hands-on on deep learning implementation. So it's a practical session. Over to you, Akshay sir.
Thank you so much, ma'am. Good afternoon, everyone. So as ma'am has already mentioned that my name is Akshay Kumar and I'm working as a data scientist at Tatras Data. So I have around 4+ of years of experience in data science, working on different projects involving NLP and computer vision and Gen AI. So I will be taking your session on hands-on deep learning implementation. Whatever you have learned in the last session, we will be seeing we will be going through the hands-on for that. So let me know if my screen is visible. Shafila ma'am, okay.
Yes, your screen is visible.
Yeah. So yes, so we will be doing the hands-on deep learning with TensorFlow and Keras. A brief agenda of what all we will be covering today. So this is a practical session on implementing neural networks, and we will be learning what is TensorFlow, what is Keras, how the neural networks work, and what are the different layers and different methods involved in these. And we will be looking at methods like compile, fit, and evaluate. How does they work? What are the different parameters that we can pass? We will be then finally creating a simple multi-layered perceptron architecture that for a real world problem, and we will see how we can train it and make predictions. And then finally we will quickly go through a CNN network for image classification, right? So before we dive deep into learning TensorFlow, it is useful for us to know that it's not the only framework that can be used to implement or deploy deep learning models. There are a lot of other frameworks present today in the market, like PyTorch, which is very popular for research purposes, and many people find it very useful to very simple to use. And then we have Keras. Kera is very much related to TensorFlow. We will have a look at it. And then we have JAX, which is also a high performance ML library from Google. And we have MXNet also. So these are different frameworks. Each one has its own strength and use cases. But here for this session purposes, we will be looking at TensorFlow and Keras only. Yeah. So the first thing is that what is TensorFlow? It is a open source deep learning framework developed by Google. Open source means that you can contribute to the code written by the developers of TensorFlow. You can use that anywhere in your projects, right? And it was developed by Google. It provides you with a set of tools for training, testing, and deploying deep learning or machine learning models. And the various tasks that you can implement using TensorFlow are like image classification, object detection, NLP related tasks, time series forecasting. These are just few. You can pick any use cases for your purpose. So what are the key features of TensorFlow? We have one is computational graphs. TensorFlow at its core, it uses computational graph to represent all the mathematical operations, which are essentially represented using nodes in a graph, and the edges of the graph represents the tensors, which are multidimensional arrays of features for the data set that we are using. And what is the benefit of computational graph is that it enables efficient execution and optimization of all the complex operations. Then the second benefit is automatic differentiation. And here we know that when we train the deep learning models, we have to do a back propagation. We have to update the weights. That's how the learning goes. And for that purpose, we will have to calculate the derivatives of the weights with respect to the loss function, right? And for that purpose, it allows you to calculate those derivatives automatically. You don't need to do it manually. So all the parameters of the models, we can calculate their gradients with respect to the loss function using this. It simplifies training neural networks. And then it provides a lot of abstraction for us. So we will have a look at Keras. Keras is a high-level API which can be used for rapid model development and prototyping. It is a kind of wrapper around the TensorFlow that allows users to implement deep learning models in a user-friendly way. Then we have distributed computing, as we know that training deep learning models where we have millions or billions of parameters involved, it requires a lot of computational power. So TensorFlow will allow us to, distribute that computation across multiple GPUs and TPUs, which are the kind of hardwares that are specifically designed to accelerate our training or inference processes. The next benefit is model serving and deployment. Once we have trained the models, we would like to deploy them in the real world use cases for the real world use cases. And it provides a lot of tools and libraries for deploying these models in production environments. Like TensorFlow Lite can be used to deploy the models on mobile devices. TensorFlow.js can be used to deploy the models on web applications. So these are the different benefits of it, and obviously it has integration with Python. Every single line of code within the TensorFlow library is written in the Python, so it allows Python developers to write the deep learning models implementation easily. Yeah. So next, then let's start how to implement TensorFlow. So I am currently working on a Google Colab environment. Here the TensorFlow comes pre-installed, so you don't need to do it here. But whenever you are working on your local system or anywhere else, you need to install TensorFlow. We will be using our the standard way of installing a library, which is using pip, Python package installer, right? So we can use this command pip install TensorFlow, and here if I run it, you can see it says that requirement is already satisfied because the TensorFlow comes pre-installed in the Google Colab environment. Then next, quickly, let's go over the Keras. As we have already said, Kera is a high-level deep learning API that sits on the top of TensorFlow, and it is basically a user-friendly. It provides a user-friendly interface to build the neural networks quickly. So whenever we have to, experiment, trying a new neural network architecture, we can quickly create that architecture using the Keras library. Here you can just see a quick example of how we can create a single layer neural network just by writing a one single line of code. Right. So whenever we are working with any packages, we have to import them, and the method to importing TensorFlow and Keras will remain as usual. The TensorFlow can be imported as import TensorFlow as TF, right? And then we can import Keras, as we have said that Keras sits on the top of TensorFlow, so we can get it from TensorFlow library itself. From TensorFlow import Keras. You can check the TensorFlow version here using the classical dunder method. Here you can see we have got 2.19.0. Now, whenever designing a neural network, it involves a lots of different layers, like dense layers. Dense layer is nothing. It is just a collection of nodes where the nodes in this layer will be connected to all the nodes in the previous layer. That is known as fully connected layer. So every neuron connects to every input. When this is the case, it is also known as MLP, multi-layered perceptron, when we have multiple layers of fully connected layers. Flatten is another layer within TensorFlow that can allow us to convert 2D images into 1D vectors. So whenever we have multi-dimensional data, which we want to convert into a single dimensional vector, we can use a flatten layer out here. Then we have convolutional layers, con 2D, con 1D, con 3D, It depends on the type of data that we are using. For simple images, we can use Con2D. It allows us to extract spatial patterns from the images. And then we have max pooling. That's also a kind of layer which is used in classical CNN architectures. It allows to reduce the spatial dimensions, basically the downsampling of the image. Whenever we have a large image, we want to reduce the size of it across the width and height. Then we have various methods that are being used in Keras, like compile, fit, and evaluate. We will go over them when we start coding the model. Okay, any questions up until now? No? Okay. Then let's start with designing a simple multi-layered perceptron architecture, and we will use it to classify the iris dataset. So it's a dataset that has some features of different species of flowers, and based on the features, we would want to classify the flower into one of the predefined categories. The first step we would be doing is we would be importing the required libraries. Here we will be using sklearn, and it is a library which allows us to load different data sets that are already available within this library. And one example for that is iris dataset. You can import it from this sklearn, and it also provides different pre-processing functions like scalar, standard scalar, or min-max scalar. We will be using those as well whenever we have some data. And then we have splitting the data. Just one second. Then we have one other utility being provided by scikit-learn, which is splitting the data. So we can use sklearn to split the data into different sets like training, testing, and validation. We have also imported NumPy, which is a standard library used for numerical operations. Whenever we have to do mathematical operations like matrix multiplications, transpose, all these kind of operations can be easily handled using NumPy. So here you can see from sklearn.datasets, I have imported load iris method. And from sklearn.model selection, I have imported train test split function. From sklearn.preprocessing, I have imported standard scalar. And then I have imported numpy as np. So I can run this cell. Its execution is completed. Then let's quickly go through the iris dataset description. It is a classical dataset which contains around 150 samples. So there are 150 data points of iris flowers from 3 different species, which are Setosa, versicolor, and virginica. And each sample is represented by 4 numerical features: sepal length, sepal width, petal width. And the task here is to use these features to classify which species each flower belongs to. So let me just quickly draw it here. Right. So this is a data set that we have. It is a structured data set in the form of a table, where you can see we have 4 different columns, right? The first column has sepal length. The second column has sepal width. And then we have petal length and petal width. So all these 4 columns have features, which are basically sepal length, sepal width, petal length, and petal width. These are the basically the parts of the flower, and these are defined in centimeters. So each row has some value for those features, like 2.9, 3.1, these kind of values out here. And in the last column, we have the label, the output label that we want to classify these flowers into. So like in the first case, it can be versicolor, In the second case, it can be Virginica, right? And so on. So here each row is representing one data point. So this way we have 150 data points in our data set, and we have these four features. We will be using these four features to classify the each flower into one of the three categories that we have, either versicolor or virginica or setosa category. So X here will be holding the input features, and Y contains the class labels from 0 to 1. So we will be defining these labels as, like for setosa, we will be taking it as category 0, and for versicolor, we will be taking it as a category 1. For virginica, we will be taking it as a category 2. So these are our three labels, and these four columns will represent the X features. How to use this function to load the dataset? You can see here we have used load iris method, and it has now loaded the dataset into our memory, and we can fetch the data and target using iris.data and iris.target, and we can store them in two different variables, X and Y. So if I run it, you can see here. Now if I just try to print the shape of X, so here you can see we have got X shape as 150,4. So 150 represents the number of data points in our data set, and 4 represents the number of columns or the number of features. And for Y, we have 150 values only. So Y was a single column vector, and here we have 4 column vectors, each representing a numerical feature. If you want to visualize it, you can see here X is a numpy array which has data something like this. So all these four values are representing the numerical features of our flowers: petal length, petal width, sepal width. And similarly, we can visualize Y. Yeah, for Y, you can see these are the labels like 0, 1, 2. So 0 will be representing setosa, 1 will be representing virginica, and 2 will be representing versicolor. So these are our labels, and accordingly, these are input features. The next step would be to normalize the features. It is an important step we always perform whenever we are training deep neural networks. And the reason behind that is that neural networks always perform better, or they train fast whenever we have all the features on a similar scale. So it can happen that some feature is in the range of 0 to 1 lakh. Some features are in the range of 0 to 1000. So all the different features are on a different scale, then neural networks might not perform well. So for that reason, we will be normalizing our feature values to make them go on a similar scale. In this case, we are using standard scaler that is available within sklearn library. And how does it work? It basically takes each data point in our data set for each feature, and it will subtract the mean of that feature from it and divides it by standard deviation. So the X new value will be X minus mean divided by standard deviation. So this is the formula, and it will be applied across all the data points for individual individual feature columns. So in this way, when we do this, we will have for each numerical feature, we will have mean to be 0, and the standard deviation will be equal to 1. So using standard scaler, we can transform each features to have 0 mean and standard deviation 1. So it will help the model to learn faster and more efficiently. So the way to use it is simple. We can just call standard scaler. We can create an object of it, and then we can call scaler dot fit transform method, which basically fits fits is like training the scaler on the data. So by fitting it, scaler will be able to learn what is the mean and standard deviation of the data already, and then it will transform it. So then we will get x here. Now if I print x here, you can see the values of each column have got changed, right? Now in this case, if you do the take the mean of each and every column, so like in this case all the rows and first column, you will find that all the mean of all the values will come out to be 0, and similarly the standard deviation will come out to be 1. So this is applying standard scalar on our input, which is only the feature values. We are not applying it on labels, right? And then after this, the next step would be to split the data set into training and test sets. So why it is important? Because we know that whenever we are training a model, we need to show it some data so that it can learn the patterns out of that data to map the inputs to the outputs. And after we have trained it, we want to evaluate it. How does it perform on the data that it has not seen while training? So how does model generalize? That is the reason we do the splitting of dataset into training and test part. For that, we will use sklearn's method, train test split, and it will allow us to split our data into train and test. So here I've just used this function and I've passed x and y both, and I have specified test size to be 0.2, which says that 20% of the dataset needs to be test dataset and rest 80% should be training. And random state is 42. That is just for ensuring reproducibility of this set. So if I run it here, you can see now out of our total samples, which was 150, we have got 120 samples going into X training part and 30 samples going into test part. So train X has a shape of 120, 4 and train Y has a shape of 120. And similarly for test, we have 30 samples with 4 features for X. Oh, sorry, it should be Y. Yeah. And similarly, test Y has a shape of 30 samples. Now we have processed our data set. The next step is to design a neural network architecture. And for that, we will be using sequential API from Keras. There are different ways to create a model. When you will start working with TensorFlow, you will find that there are other ways to create a model similar to this sequential method. There are functional method and subclassing API, and each one has its own purpose. But here, for simplicity purposes, we will be using sequential API. So how we can use it? We can define a method here, keras.sequential, and inside this method, we need to just pass a list of all the layers that we would want to see in our neural network architecture. So here you can see I have used keras.layers.input method, which is telling that model has the first layer as input layer and it has a shape of 4. We don't specify here the number of samples because it will be varying whenever we will be training depending upon the batch size. That will always vary. So we just need to specify the number of dimensions of the features. So we have 4 features here in our iris dataset. So we will be specifying a shape of 4 like this. And the name, we can name it by passing a simple name here, input layer. And then the next layer that I would want to use is dense layers. And dense layer is a layer which essentially represent. So if we look at here, if this is our input layer, we are saying we have 4 features out here, right? These 4 features are an input layer. Next, I would want to connect it to another layer which will have how many neurons? 16. Units equals to 16. So 16 neurons I want into the next layer. So I will specify here 16 neurons out here. So these will be 16. Here we have 4 neurons in the input layer. So this is my first hidden layer, which I am representing as a hidden layer 1. Right? So then we will have automatically connections being created from all the input neurons to the hidden layer neurons. Okay, so this way we will have connections all the way. And next, we can also specify the activation function that we want to use after we have done this computation of input, which is our x, let's say, multiplied with weights. Let's say this weights, the weights on these edges are w, and then we will be adding one bias, and then we need to apply a activation function out here. So activation function, we can specify it here, ReLU. We want to use a ReLU activation function. So every value that is coming out of these 16 neurons, we will apply a ReLU activation function on that, just to ensure that we are adding some non-linearity into our architecture. Then similarly, I want to create one more layer with 16 neurons, and in the final layer, I would specify the number of neurons, which is equal to the number of classes that I have in my data set. How many classes we have? We have 3 classes. One is Setosa, second is Virginica, and third is versicolor. So we need to specify 3 neurons out here. So in this way, my architecture looks something like this. This 16 neurons are next connected to another layer of 16 neurons. And then finally, we have a output layer which is having 3 neurons. So all these layers have connections to one another. Right? So in this way, we will be getting output from this final layer. Now this will be giving us some real number values like 7.5, 4.3, these kind of values. But we want to convert it into a probability distribution where we will have probability of our input, a single input, which is our flower. We want to classify it into one category. So for that reason, we would want to see a probability distribution out here that tells us what is a probability that our input belongs to one of these 3 classes. So it can happen that we find that this has a probability of 0.75, this has a probability of 0.20, this has a probability of 0.05. So in this case, you can see the maximum probability we are getting at the first output neuron, and we can say then this input belongs to class 0 because the first neuron has high probability. If this last neuron has a high probability, then we will say the input is of class 3. So this way we can design it here. We have specified in the final layer activation function to be softmax. Why softmax? Because softmax allows us to convert a output values to a probability distribution. So here you can see I have just passed this list of layers to this sequential method. Sequential method basically tells the underlying architecture that each of these layers is connected to one another in the sequence. So I can then store it in a variable model MLP. So if I run it now, and we have a method here which is summary method that allows us to display how the model looks like. So if I run model MLP dot summary, you can see I have first hidden layer, second hidden layer, and third output layer. And how many, what is the output shape from each layer? From the first hidden layer, the output shape will be none, 16. So why none? None is basically represented the number of samples. So as we have already said, it will be replaced with the number of samples in the batch, and batch size is, you know, batch size can vary. So it will be none at this point. So then second hidden layer also we will have none, 16, and in the final output layer, the output shape will be none, 3. And you can also check out the number of parameters here. In the first hidden layer, we have 80 parameters. In the second hidden layer, we have 272. Third layer, we have 51. So total parameters are 403, trainable parameters are 403, and non-trainable parameters are 0. So this means the model will be training on these 403 values. So we have 403 parameters or weights in our network that we need to train. Next, we have now defined the architecture But the next step would be to compile the model. Compiling basically configures the model with the optimizer, loss, and metrics. So optimizer basically tells you how how to update the weights once we have calculated the derivatives of weights with respect to the loss, how to which equation to use for updating the weights. For that reason we are using here Adam. We can also use stochastic gradient descent, or RMS prop. There are various options available. And for loss we can use sparse categorical cross entropy. So this is a specific loss that we need to use whenever we are working on a multi-class classification problem and the values are integer labels, right? So just remember, for multi-class classification with integer labels, we can use this function, loss, sparse categorical cross entropy. And then metrics is basically telling us what are the different metrics that we want to use to monitor the model's performance. We want to use here accuracy, how accurate our predictions are, how many predictions that model has made are correct. Then we can just use a compile method on this model MLP that we have defined, model MLP.compile. We can pass these three different parameters and it will compile our model. After we have compiled our model, we can start the training of the model. For training, we will use fit method here, and different arguments that it take is that the first argument is x train, the second argument is y train, which are basically the training data sets respectively, right? The input features and the output labels. Then we need to specify the epochs. Epochs basically tells the model how many iterations of training it has to do, how many iterations it will do the forward propagation and then the backward propagation. Then we have validation split. Now once we have got the training data set, we would also want to split it into train and validation. Validation is the one which we will be monitoring while uh, you know the model is getting trained. We will be monitoring the metrics on validation data set so that we can see what is the performance of our model. So here we have specified point 2, which tells us that out of a training dataset, use 80% for training and 20% for validating. Then we can use batch size. Batch size 32 here means that we will be using 32 samples one at a time, and we will be doing a forward propagation, and then we will be calculating the loss, and based on the loss value, we will be doing the backward propagation. So the weights will get updated. So the model will see 32 samples at a time and it will do a back propagation. Then we have verbose here. Verbose basically tells the model it has a value 0, 1, 2. So 1 means that show the progress of the training. Then I can just call this fit method. Here you can see when I'm calling this method, model has started training. It represents the epoch 1 out of 100. So we are training it for 100 epochs. And in the first epoch, we can see how many batches we have. 3 batches. So 32. What was the shape of our X train? It was 120. And here you can see out of 120, we have used 20 for validation, 20% for validation, and 80% for training. So 120 into 8 is 0.8 is 96. So we are using 96 samples for training. And if we divide these 96 samples into a batch size of 32, how many batches we will get? 3 batches. So 96 training samples will be going into the network, but only 32 at a time. So after 32 samples, it will update the model weights. So for 32 samples, it will go with the forward propagation. It will calculate the loss. It will do the backward propagation, update the weights. So this way, how many batches we have processed in one single epoch? 3 batches. You can check out accuracy here. Accuracy on training dataset is 0.34, which is 34%, and loss is 1.11. Validation accuracy, the accuracy on validation dataset, which is 20%. Similarly, you can check out the validation loss. So here you can see that the model has been trained on 100 epochs, and by the time we reach at the 100 epoch, the accuracy on training data is quite large, which is 94%. We started with only 34%. But by the 100 epochs, model has been able to accurately classify the images based on the features. So validation accuracy is also high, which is 95%. If both accuracies are high, then we can consider that model has learned a lot of patterns within the data. Basically, it is able to classify unseen data correctly as well. Now, after the model has been trained, you can check this history object, which is here. The output is being stored in a history object. You can check history has another method, which is dot history, and you can check out the keys here, which are essentially accuracy, loss, validation accuracy, and validation loss. So these are telling us that if we check it out here, if I want to see accuracy, that will look like this. It is an array of 100 samples, which is telling what was the accuracy at the end of each epoch. So that at the end of first epoch, this was the accuracy. At the end of the second epoch, this was the accuracy. So in this way, we can check all these four values. The next method we will be looking at it is evaluate. It allows us to test the trained model on unseen test data. And this is basically the training, right? In the training, we had a validation data set, which which we were monitoring just to ensure that model is able to learn the patterns in the data. And after the model has been trained, we need to evaluate the model on unseen data. So you remember that in the starting, I split the data into two parts, train and test. So I will be using this test data set now, which is unseen data. It was not seen by the model either in the training process or in the validation process. So I can just use model MLP dot evaluate. I can pass X test, which is the features, and Y test is the actual labels. So if I run it, you can see I have got loss as well as accuracy on this data set. You can see loss is very small, 0.16, and accuracy is 100%. So on the unseen data set, the model is performing 100% correct. So what are the number of samples we have in test data set? All the samples have been correctly classified by the model. Right now, the next method is model.predict. So this was all up to training and evaluating the model. Once we have got our model trained, we want to deploy it, and we want to make the predictions maybe in real time, or we want to deploy it on server, and we would want to see how it performs on the individual samples whenever we want to predict uh, on them. So for that, we can use model.predict method. So you can see here, I have just taken a random index out of the dataset, which is 5, and I can fetch the X and Y value for that index, which is stored in sample and label variable. Then I need to reshape the sample so that it is in the shape of batch size, comma, the size of the sample. So 1 is the batch size, and -1 here just represents the whatever the shape of X test was, keep it as it is. So in this case, it would be 1 comma 4. 1 comma 4, that is batch size, comma, number of features. So it will be 1 comma 4 because we are predicting on only one sample. And once we have reshaped it, we can use model MLP dot predict method, and we can pass the reshaped sample. We can get the prediction. Now prediction, as we know, it will be a array of 3 values with some probabilities, like 0.9, right, 0.5, 0.06, or 0.04, these kind of values, right? So then we can use np.argmax. Argmax will tell us the index of the array at which we have the maximum value. So what index we have maximum value here? The first index. So it will give 0. So here you can just check it out. What was the value of prediction? Here you can see we have an array which has maximum value at the first index, which is 0.98. So predicted class will be first index, that is 0. If we print actual label and the predicted label, we can see both are matching, both are getting 0 value. So in this way you can use your trained model to make predictions on individual samples. So this is a real world use case. Just imagine you have some kind of data set you want to train your model on, and once you can train it, then you can just deploy it somewhere, and users can use it just passing the input, and they can get the output correspondingly. So how to do that is by saving and loading the trained model. You can save your model. Suppose you have a model trained and you want to share it with some friend, or you want to uh, take it to some other system. How we can do that? We can use methods available within Keras library, which allows us to save the model using this model.save method, and there is another method which is load model. Both methods allow us to save and load the model back. So we can save model architecture, the trained weights, and the optimizer state all once using model.save method, and we can just pass this .keras uh, uh, file name, right? So whatever the file name that you want to give it here, and extension should be .keras. So it will save the complete model in the keras format. After we have saved it, we might want to load it back, and how we can do that? Using load model function available within Keras library. So you can see I have tried to save my model using model mlp.save method, and I want to save it in the content directory with the name iris mlp model.keras. Now if you see here in the content directory, we have got iris mlp model.keras being stored. You can download it here. You want to use it on your local system, you can do that as well. So once we have saved it, we might want to reload it, and we can use load model function, and we can just pass the path of the file. Here you can see loaded model has been this model has been loaded, and you can check out the summary. It is same as we have used. So these are the different functions, basic functions available within TensorFlow library that you can use to design a neural network architecture for training your uh, deep learning models. And for deep learning models, we need a lot of data to train them on, so that our accuracy and other metrics that we want to monitor can be efficiently trained. Any questions, anyone? You can check the documentation of TensorFlow Keras. There are all the different layers available here. So if you look at the layers, we have different layers available: Con 1D, Con 2D, Con 3D. Those are CNN layers that we use for image classification. And then we have LSTM layers, RNN layers that we use when we deal with the sequential data like text. And all these different layers are used somewhere in the different applications. And similarly, if we want to see what loss that we want to use, we can check it out here in the tf.keras.losses. We have mean square error, which we might want to use when we are dealing with a regression problem. And we have binary cross entropy that we might want to use when we are dealing with a binary classification problem. So based on the application that we are trying to use case that we are trying to solve, we might want to use a different loss function. Then we also have different metrics available within it, like accuracy, binary accuracy, categorical, hinge, cosine similarity, F1 score. All these metrics we might want to use for our specific use cases. We can use these, and here we have documentation corresponding to model. So the sequential model that we have used, you can check out compile method here. It has a lot of parameters that you might want to try out. So you can check this documentation optimizer. It says the name of the optimizer that we want to use, right? Similarly, you can check out other parameters of these functions. We have fit method here available. We have load weights. We have save method here. We have predict method here. So the documentation, clearly mentions the functionality of each and every function that we want to use, and all the parameters that we can try. Any questions, anyone? Okay. Uh, this was a simple MLP, and I have an additional, thing here that we would also want to see, which is how we can build a CNN architecture. The architecture that we just went through, it was simple MLP architecture, which we used for a data where we have numerical features and we want to classify them into some predefined categories. Now here we would want to use CNN for image classification problem. Why use CNN? We know that it is better for image data. It allows us to detect different edges, different textures, or all the different kind of features which are present within the image. It is more accurate than MLP when using it on images. So what we will be using here is MNIST dataset, which is a most popular dataset within machine learning and deep learning. It contains around 70,000 grayscale images of handwritten digits from 0 to 9. So digits like these 7, right? So this is a grayscale image of 7 digit. So we have in this data set all the different images of different digits from 0 to 9, and each image is of size 28 by 28 pixel. So the breakdown of the dataset is something like this: that we have 60,000 training images, 10,000 test images, and each image is a grayscale image of size 28 by 28, which is width across height, and the pixel values are ranging from 0 to 255, and we have only one channel, which is grayscale. In the case of RGB images, colored images, we have 3 channels, but in the case of grayscale images, we have only one channel. And the goal is very simple. We would want to train a CNN architecture for this problem, where we can learn the features from the images so that we can correctly classify them into one of the 10 digit classes. That is either images of digit 0 or 1, 2, 3, 4, 5, and so on up to 9. So how we can do that is another library within Keras, that is datasets, and which will allow us to find preload the MNIST datasets. We don't need to create it on our own. We can just load it from keras.datasets.mnis. We can use load data function, and it will load the dataset into train and test part here. So here you can see we have loaded it: x train, y train, x test, y test. The next thing I would want to do here is again normalize the pixel values. How I can do that? I would first reshape the images within train and test. How I can do that? Reshape -1, which will tell us whatever the shape of it was, and we would want to reshape it into 28 by 28 by 1, which is 28 pixels across width, 28 pixels across height, and then we have 1 for channel, grayscale channel. I can just divide it by 255. Why 255? Because we know that our pixel intensities are ranging from 0 to 255. So the maximum value is 255. If I divide it by 255, the maximum pixel value will be 1, and all other values will be ranging from 0 to 1. So in this way, I can normalize the data, and you can check out the shape here. The X train has a shape of 60,000 images, and each image is a shape of 28 by 28 by 1. Similarly, Y has a shape of 60,000. And then we have X, test X has shape of 10,000 samples, and rest everything is same. Again, I am designing a simple neural network architecture using sequential API of Keras. I have created different layers. First one is input layer, which is 28 by 28 by 1. And then we have con 2D, max pooling 2D, con 2D, max pooling 2D, flatten layer, dense layers. And in the final dense layer, I have put 10 units. Why 10? Because the number of classes that we have are 10 digits from 0 to 9. There are 10 classes. So in the final layer, I have used 10 classes and activation function of softmax, which will basically convert the values into a probability distribution. So in this way, I have designed my architecture. I can see the summary of this. You can see how the different layers are now stacked one after another. And in the final layer, we have dense layer of 10 neurons. These are the parameters within CNNs. I can compile it using, let's say, Adam optimizer this time. Loss is again sparse categorical cross entropy. Metric is accuracy. And if I train it for 5 epochs with the 10% validation data, I can see for 5 epochs, I have got this accuracy on training, 99% accuracy on training. And for validation, I have got 99% accuracy again. Then we can do evaluate on our test data set, which is our unseen data set. We can see we have got 98% accuracy on test data set, unseen data set. That means our model is doing good. Next, I would want to predict it on us, use a predict method on a single sample of input. So I would just view this sample, which is a random sample from a data set at index 0. You can see it is a 7, it is a image of 7 digit. Then I would use this sample image. I would reshape it into a batch size of 1. I would get this and I would use predict method on this input. I would get the prediction. I can do a argmax out here to find out the index of maximum probability. And I can then just compare the actual label versus predicted label. So you can see actual label is 7 and the model also predicted as 7. So this way we can use CNNs for image classification. Now, the only difference between the two approaches was that kind of layers we are trying to use within our architecture. Here you can see that for image classifications, we have to use layers like con 2D, max pool 2D, and dense layers are very common for each and every kind of architecture. So these are very specific to con 2D are very specific to image kind of problems. The different parameters that are involved within each of these layers. You can check out this documentation here. Here in the layers, if we look at con2D, you can see this. The first argument is specifying the number of filters that we would want to use. Next argument is specifying the kernel size, what padding we would want to use. So all these things are related to the architecture of CNNs. Once you have got a good understanding of that, you will get to know what parameters values we need to pass it out here. So just a quick recap, we saw how we can use deep learning models to train it on our data sets so that we can use a supervised learning where we have data sets where we have inputs and outputs values being provided. We can split them into training and test part. We can design a sequential neural network architecture with dense layers. We can specify activation functions. For CNNs, we can use different layers like convolutional and max pooling, and then we can just train it for a few epochs, and after training we can see what is the accuracy and loss, and then we can evaluate the model on a test data set, and after that we can deploy it using, we can make predictions on individual samples just using predict method. Any questions, anyone? That was all from my side. Okay.
Akshay sir, there are questions in chat also. Can you please see that?
Okay. So how to use it over continuous time series? Dhiraj Singh, I see this is a question from you, and we can use, we can design a RNN kind of architecture where we have to use RNN or LSTM layers specifically, because those are the kind of layers we have pre-built to work on sequential data, the data that is varying with the time. Okay, 16 is neuron in hidden layer. Yes, 16 was the number of neurons in the hidden layer that we used. But if there is too many units, it will call overfitting and vice versa. It's not the case that having too many units will cause overfitting. It's just that the number of neurons is a hyperparameter based on the problem that you were trying to solve on what kind of data that you have. You will have to tune the number of neurons in each layer so that you can check out what is the output of the model. Is it doing better or not? It's not at all that we have whenever we have whenever we specify a lot number of neurons in the hidden layers, we will always overfit. It is not the case. Yeah, it is a design choice. 16, we can use any number of neurons. It is a hyperparameter.
Okay, I hope that all the queries have been resolved till now. Any other questions you are having?
Okay, but we can't change the hyperparameter. No, you can change the hyperparameter values. So you have to do the different experiments. Like in this case, when I tried to train a model with let's say 16 neurons in this case, right? I would see what is the accuracy of my model. Is it doing better or not? If not, I will have to revisit the model architecture. I will have to change the number of units. We can change the number of units within each hidden layer. We can add more hidden layers as well, right? We can change the activation functions. So all these are kind of hyperparameters that we can tune in order to see how the model is performing. Okay, any other questions?
Uh, okay, I hope all the questions and the queries have been resolved till now. Thank you so much, Akshay sir, for joining the session and making this session such an interactive one. So, before moving on any further and ending this workshop day, I want you all to fill this feedback form as it will help us improve the things. If you find anything good, any difficulty in today's workshop or anything, we can surely check over your feedbacks. Okay. So, any other queries or anything you all want to have a discussion about or not? Because we have tomorrow's date and we have tomorrow held a doubt session for you all as well, right? Shafila ma'am, do you want to mention anything?
No, I just want to say tomorrow we will be starting at 8:30. So the first session will be by Dr. Sukhjit Singh Sehra, the co-founder of Sabudh Foundation, and second session will be at 9 by Dr. Sarabjot Singh Anand, again Chief Data Scientist and co-founder of Sabudh Foundation. So he will be walking you through generative AI, Dr. Sarabjot Singh Anand at 9 a.m. And Dr. Sukhjit Singh Sehra will share the opportunities at Sabudh and career pathways in AI. So we hope all of you be there at 8:30 tomorrow. Thank you, everyone.
Thank you so much, everyone.
Thank you, Rakshita. You can stop recording, I think.
Sure, ma'am. Kindly fill the form. Those who are leaving now, please open the link and you can end the call from your end. And please do fill the form, okay? Yes, Jairam, you can leave.